All right, put that up. How are we doing today? Time to get back into programming. I said I'd do burn the subs, but I lied. Like completely up and down swore that we would work on burn the subs, but this thing has been on my mind and I haven't been able to work on it this weekend. I've been uploading videos. I am scheduled until the end of the month, but I want to get way ahead of that, so it's been a little bit of a chore. I think I did 4 yesterday, and that got me ahead of, because yesterday, in terms of the videos that I'd uploaded and scheduled, I was 1 day ahead. So I've done 4, and that's taken me out to the end of the month, but I think I did more than 4. I forget. I was only a day ahead. 1, 2, 3. Oh no, I did 5. Yeah. All right, feeling hot and cold. My stomach is rolling around right now, but I think we'll get through stream all right. Let's pop out a YouTube chat so I get chat on the screen. We're gonna do some like hardcore programming. It's gonna be Arduino programming, but it's like a necessary step because you want to build a framework and then you put your functionality into the framework. But part of that framework, hey, V Nukem, ready for Easter? Yeah, I'm not doing anything. I don't have to do anything with the nieces and nephews. I don't really celebrate Easter that much because it's a candy holiday. It's a holiday for candy and religions that I don't really keep up with, so it's not really a thing. I don't really do Easter. Still happy to give candy away, but it's generally not something I do. All right, let's pop this out. Pop out chat. There we go. Hopefully the poke bowl was all right that I ate. Sure, he sure did. He sure did, sport. Let's do that. There's the YouTube chat. There we go. Yeah, so in recent news, Bridgent, we had a cargo container crash into a bridge in Baltimore, which is just south of where I am, like not even that far away. It's like maybe a 10-15 minute drive for me to get there. I never go on that side of Baltimore though, because Baltimore has the Beltway and I-95 just goes right down through, and so I just take I-95 through generally to get where I need to go. Sometimes I'll go Route 1 out and then down from there instead. Well, it's the opposite way you guys are viewing it. So Route 1 takes you out west and then you go down. Or no, I-76, I forget which one it is. There's like an alternate route that takes you kind of out and around. But I almost never do the Maryland Beltway. I think I've only been there twice, maybe twice I've crossed that bridge, just because I took the wrong turn and I ended up going around the Beltway. Yeah, I was reminded of the Later Alligator, the game Later Alligator, the adventure game, all hand animated, really good game. Great soundtrack, so I'm playing it right now. Hopefully it's not completely copyright. It's not a complete, you know, ghost town of copywriting, but here it is. By Too Mellow. It's a really good soundtrack. I wonder what else Too Mellow's worked on. I need to move the fan. I'm like hot and cold. I don't think I'm sick. I don't think so. I might have just eaten something weird. Body decided to eject everything before stream. So we're gonna frame up this program with respect to it being on 2 different systems. So there's potential for there to, instead of one of the switches, we'll have another analog input. And then we need to figure out how we're going to be mixing all of the signal values. If there's a better way to do it than just adding them up and then constraining it. Weird. It's adding them up and constraining them is a weird system. I'd like to look at some other code that does the mixing. So we'll have to dig something up and figure that out. Bengizmo was kind enough to put all of our polynomial equations into what Desmos, I don't know what that is, just like I guess just a thing you can do, and give them a mod value. So you can actually look at these equations, and the URL is in the Google thing. I'll put it in chat right now. I'll have to probably put it in chat again later on, but and you can just fool around with these polynomials and what they do to the waveforms. It's really cool. Really, really cool work from Big Gizmo. I appreciate this greatly. course, you can't really see the whole equations. They're big. They're not small. We'll look at them again a little later on. Bleh. That's got to be a filthy wave. Why are you pushing that on me? I'm not going to do that. Kidding me? 5 head. I may have a 5 head right now, but I'm not going to build one of those. Hell no. That's such a huge project. Let's see. We're not going to need the scope much. More of what we're going to need is basically just looking at this and how it's going to respond to our serial prints and all that other stuff. Going on Twitch. Index C. So we had Veet Nukem sub for 29 months, and then Index C for 35 months. Hell yeah. Thank you both of you. I really appreciate those subs. No message in the sub, but definitely a strong sub. Thank you. Yeah, we're getting into the microcontroller a little bit more because I haven't been able to work on it. I've been working on uploads and creating wonderful thumbnails such as this one. Remember when I didn't have a bunch of hair? I need to do this to myself soon. I'm going to see if I can get an appointment on Wednesday to chop off all my hair. I'm not in any particular rush. It's just that I get more comments around here for some reason. People don't like it when you don't look normal. They don't like long hair. I had an English teacher in grade school that had a mole almost exactly. Is that a mole or is that it's just a reflection? Okay. I was afraid I'm going to get a mole right near where my circles under my eyes are. Reminds me of an English teacher that was pretty strict. Beep. Computer music. Beep. I'm hoping that eventually this synthesizer will be able to actually make some pleasant tones that can fill the background of stream, because that would be something very worthwhile to me, is just having something that'll make sort of wibbling noise in the background that's not offensive to listen to, and then I can talk over it. So, hey, what's up? How you doing? Yeah, but we're gonna get to this synthesizer. Of course, I'm gonna need new circuit boards, because they've all got these bugs in them that are very difficult for me to get rid of. I have a pin swap that has to occur basically down in this transistor down here. I probably should build up one of these, though, one of the cord VCOs, just to make sure that everything works in it, and that the 2 edits are the only 2. I did not forget to deactivate it. How do you think that works? What do you think occurs in a stream? I'm actually curious about this. What do you think occurs when there's a starting soon logo up? It's basically, on my end, it's no different than actually streaming, because I've got all the software running, got all the windows up and set up. Everything is exactly the same, only I'm running an overlay that says stream starts soon. So when you see like a splash screen or something, this is exactly what's going on. There's nothing special or inherent to the streaming platform that gives you a starting screen. And this is something I rant about like almost once a stream. Hey, what's up, Guned? Almost every stream I end up ranting about this, because somebody's got to ask every single time. Nothing is different. I'm not activating something on the platform that says starting soon and it has like a timer on it. People just do that. They just have that overlay. Yeah, exactly. Yeah, I was thinking of not even having an intro today, just because I wanted to jump into actually coding, and I felt like I slept under the bed. Actually, I was crowded to the very side of the bed by my dog. She decided to hang out with me last night, and she took up most of the bed. You solder in wires to your defective boards to change the path to verify the design. That's exactly what I've done. Yes, that's what you have to do, because you may not just have one problem, right? You see one problem and you're like, oh no, I have this one problem with my circuit board. I have to change this pin to that pin. So you do that, and you get the rest of the circuit board functioning so that you know other problems. We found a couple other problems once we found the one pin needed swapping. We found out that the button doesn't actually work because it was wired wrong, because the part that I made had the wrong pins as the button pin. So I corrected that one. And even before that, we discovered that the power connector was in upside down. So problems like that are exactly why we do what we do. This is exactly why we build up the board and we get it fully functioning before we do our second revision. Bodge jobs are the name of the game. That's the name of the game. Drink coasters, yeah, I know. Or if I need to, like, I don't know, cut them up and build something with them. They're really not that good of a size, though. And it's I can't do much with these. I'm just going to order them again. It's not worth my time, you know? It's one of those time is money gigs. If I wanted to bodge something together, I guess I could use them, but they're not exactly, like, super useful to me as, like, a spoiler for the RC car or whatever. It's a little wide for a tongue depressor, though. I like the yellow ones. I don't know if I want to order 2 yellow boards, though. Maybe make one green and the other yellow. I don't. The green is so boring, though. Red is too serious. Maybe blue is a little whimsical. There's no like purple at Seed Studio. They need to get purple. They need purple. They just have all the boring colors. But we discovered that yellow is actually pretty nice. It's a pretty nice looking board. Pretty nice looking board there. It looks pretty good. Yeah. Yeah, we're going to try to get this thing working in terms of like a skeleton program so that all of the functionality is there and it like saves what mode it's in between power cycles. So we need to get into EEPROM. We need to do, I mean, we've mostly got the program already kind of framed out, but I need to get the program running so that I've got the printouts to serial and they tell us what the values are. I need to build an LED blinking engine. We need something that has several entries in an array and just moves the entries through the array based on the timings given. So if the number isn't 0, then it should wait that amount of time until the timer expires, and that's going to be something we need to figure out. I need to figure out how that code's going to click through all of its stages. I'm entirely made of hair. I'm at the point where my hair starts to hurt at the end of the day because of the length. Definitely need a haircut. That's what we're playing right there. Too Mellow, Later Alligator soundtrack. It's actually a wonderful game. It's a very fun game. Yeah, you can see the mod that we did back here. Just the bodge wire. Making it work. This is just looking at our PWM. And then the Sallen key filter is what turns that PWM into a normal wave. I don't know if I may want to go back on the resistors that I put in the Sallen key filter. I don't know if those 100 kilo ohm resistors are really doing anything. I don't really think they're doing a whole lot. I think the filter's already pretty well tuned to the range that it needs to be tuned to. Right. Oh, I need to make sure that Arduino is closed on the other computer. It is not. Let us close it. Close Arduino on the other computer. Luckily, the files that I'm working on are on the server, so I will just simply open up Arduino over here and open the files, and they will be all set. Working with 2 computers. Let's try to save it. Come on. There we go. Let's go like right Yeah, the light is right there. Okay, right there maybe? I was bringing in this light will change everything. And then I block the thing. That's why that on-screen oscilloscope is a good feature to have. Oh, we need to get the power supply going. All right, let me unplug this back here. I guess, actually it's easier if I just do this. There we go. Plus 12. Got to turn the output on in order to adjust this one. 12 volts positive. 12 volts negative. And 6 volts is our playground for our CV inputs. That's all plugged in. Yeah, we're currently sending 6 volts into this, but that should be fine. And then we plug it in, and we get a wave. And our LED turns on for some reason. But our LED turns on and off with a button push. That's where we got to with this thing. Look at that waveform. Beautiful. Get rid of the thermal cam actually for this view. Not strictly necessary, although on the back of the board you can see some of the temperatures on the board. Things get warm, they don't get hot. Ooh, I hate it. I hate that feeling when you're just starting to stream out and your guts start kind of rolling around. There's probably going to be a BRB at some point where I have to use the bathroom. I don't know what the hell I ate. Body's like, I don't like that. I don't think it was the poke ball because I only just ate the poke ball. Probably some weird bullshit that I ate last night. What did we have last night? What did we even have for dinner? What was that? What did I eat? Oh, it was it halibut? I think it was halibut. It was fish. We had fish last night. And then I had fish today. That's a lot of fish. Possibly to the detriment of my own digestive system. Shall we get started? There's not a whole lot going on, except a fucking bridge collapse in Baltimore. Holy shit, if you've seen that. Cargo vessel lost power during kind of a critical stage of going under a bridge, and it drifted and then collided with pretty much one of the most important spans of that bridge. It was a suspension-ish kind of bridge. One of those ones where you have the metal, like, you have like the triangle work metal frame that goes up and over, and then the bridge kind of goes along that and suspends from that at one point. And that usually there's like big, what are they called, like ducts or something like that are around the pylons of the bridge that keep things like cargo ships from colliding with it. But the cargo ship was a very slow onslaught, and it just sort of drifted into that pylon and destroyed it, and it almost immediately collapsed the bridge. So there's like an Amazon warehouse near there. It's like a pretty big shipping lane, especially being in the Northeast. There's a lot of cargo ships going in and out, and now they can't. So that's going to be kind of a thing for the next couple years. It's what are they going to do about that? That's crazy, 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 crazy. I'm gonna have to assume that some national funds are going to get activated to build a new bridge. If I wanted to be really callous about this, I could do that bridge building game, the engineering bridge building game that I think Rob played a couple months ago. More than a couple months. It might have been a year ago. I actually bought the game, and I meant to do some streams with that. It was like the Bridge Building 2 or something. It was the follow-up. There's also Engineer that came out more recently. that I was hoping to play at some point, and I just got too busy. Life got too weird for me to do gaming streams at around that time, and I'm coming out of that soon. We'll do some gaming streams in the near future, but boy, oh boy howdy, doing a bridge building stream would be kind of funny right now. I say kind of funny because, like, there only 6 people missing, right? This could have been a much worse thing. If this was not at 1 o'clock in the morning, it would have been an absolute disaster. It's still a disaster. It's still terrible. But in terms of like the what could have, I don't think there was more ideal of a time. And they did send out a mayday, so bridge workers were able to kind of shut off traffic. And some people still insisted on going over the bridge. Like, how inconvenient that a ship is about to crash into the bridge. Like, Jesus Christ. So yeah, there's I laugh because it is a lot less worse than it could be. It's still a big thing. It's still a tragedy. But, you know, whatever. Ain't my bridge. Beep, 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 beep. All right, let's get started. Get the music out of here. I just thought this music was charming. But that's Two Mellows soundtrack of Later Alligator, which is a wonderful game, a hand-animated game. All right, so setup, start soon goes away. What are we working on? Well, geez, the amount of engineering know-how that's being called upon right now nationally in order to comment on a thing that I have no know-how about. I am an electrical engineer. I do not do civil engineering. I know Engineering 101 for that sort of thing, but man alive, that's a crazy thing that happened recently. Moving on from that, what are we doing today? I am going to be in my element. I'm going to be programming microcontrollers. We're still working on the VCO, right? I want to get this VCO done. It's a fairly good VCO, actually. It does a lot of really cool stuff. And I would love to give it to Julian and Dave. Just give them both of them. So I'm at least going to have to build 6 of these things, and I want to make sure that everything is good. I don't want to just put random software on there. Hajiwo made a program that works. I don't know if I agree with some of the ways that it works. Like, every single time you touch something, it makes a whole new table. Like, almost every cycle, it's making a new table, which is a little weird. Of course, if you are twiddling the knob, I guess that makes sense. And the speed with which it makes the new table is incredible, because we're talking about an RP2040. I just shoved a bunch of food in my mouth. I'm sorry about being a little irpy. I try to eat a little earlier to keep that from happening, but it didn't happen today. Anyway, in order to do all of this stuff, I mean, we've got a thing that gives us all of the polynomial equations for the FM modulation, which does some really, really cool stuff. It makes some really cool like waveforms out of it. What's up, Jude? But now that we know a little bit more about the polynomials, I find myself getting lost while programming everything else. And so I need to restructure this whole program. I need to make it work in the way that I like things to work, which is a fairly niche sort of Arduino style of programming where things are sort of set up very carefully, I guess. I don't know. It's just the way that I like to look at code. So we're going to try to get it to do that. To look like the way I like to code things, and maybe it'll make a little bit more sense in our minds. But first, before we even get into the polynomials, I need the whole rest of the program to work. There's a whole layer of interactivity that needs to function before we get down to those equations. So that whole layer is basically the inputs is what I would like to figure out here. We have a button, we have 2 switches, and we have 2 potentiometers with control voltage inputs, even before we get to the main output. So what I'd like to do is set up set up the RP2040, this guy in the back there, to go through the modes, give us a little indicator of what mode we're in, and then scale the inputs and have areas where I can call upon functions in those areas, right? So that's the plan. That's the plan. Let's get started, huh? So I think I already have Arduino running, but it's got old software in it. Look at this old software. So let me open up something new. Well, actually, what we're going to do, you know what I should do is start just a whole new program. So we'll start with a whole new program. So I'll just file new, the tried and true. Looks like my viewer is here. I've got my one viewer. I do what I want, and sometimes that's boring programming. But welcome to the show. So I'm going to save this as, and this time I'm actually going to put it in the proper folder. So in my, what is it? My network drive. That's not it. I have a shortcut on the desktop because I'm a boomer. Do I have a shortcut on the desktop? Where's project? Oh my God, I have way too many. I have way too many folders on the desktop. I really need to clean this computer up. What are you doing? Windows cannot access. Cancel. Cancel. Wait, why not? Hold on a sec. I didn't reset this computer, did I? Let me take a look here. No, we're fine. Oh, I wonder if that link is old. Maybe that's an old... Actually, are we... No, we're not even close to the... So anyway, we're going in here. There we go. Stream. And then we go to... this would be synthesizer. Synth. The whimsical names of projects are starting to get to me. I'm starting not to be able to find things. Synth. There we go. And then we are in the RP2040 VCO chords. And then this one's going to be 2040 VCO. Let's just call it framework. Call it framework. Too many folders, PTSD. Yeah, really. You just kind of shut down. You're like, I don't know what I called this thing. And then you look up the folder name and it's like sillyguy.exe. You're like, wait, what was I even thinking? Setup and loop, right? We were a normal Arduino program. We have a setup and we have a loop. Setup runs once, loop runs repeatedly. We need a header for this whole thing. So let's go up to the top of some other code. Actually, we're going to close this one. I'm going to reopen the program because it has some extra work in there that I did over the weekend. I did a little bit, but I didn't really do that much. I kind of looked at my code and my whole brain shut down. So the test is where we're working on right now. Where did the thing that I just saved go? Sketch March 26. Wait, that didn't change names. Well, I want to open that up, but I also, did this not save? Save canceled. Wait, did I hit cancel instead of save? I think I did. I think I just did that. Hey, BrinkGG, what's going on? Save as. And then we're calling it, we're going into, where are we? This is the Arduino folder. We're actually going into project LMNOPQRS. You know things have gotten bad when there's just new folders sitting in your project directory. Oh, we're in stream. And then synth. There we go. And then this is the RP2040 VCO. And so RP2040 VCO frame. And I just hit save. Saving. Done save. Okay, so it's not, there wasn't a problem. I thought there was some kind of problem. It's just because I'm distracted by everything that's going on. Okay, so I'm going to steal this for a test program, and then this one is the RP2040 VCO functional framework. Get rid of that, and then we got links to Hajiwo. We have the math stuff explanation. I'm gonna put in Ben Gizmo's contribution, which is pretty cool. I have what do I have open? I have some studio program open for updating my insulin pump software. I need to do that at some point. I need to recompile. For the freak polynomials. And then, let's see, our inputs are reversed, blah, blah, blah. I should have a map of all the pins up here, but I haven't done that yet. Instead, I mean, we're obviously taking hardware PWM and bounce too, and we're moving all this stuff in there. So I'm going to grab that, and I guess these down here too. I probably should rewrite these because it's like PWM wrap, PWM CD, PWM CD IV. What the? Oh, system clock resolution times frequency. Okay, so that's some calculative stuff. But it's 1. Why is it 1? Number of octaves, 6 octaves. The resolution is 1230. Frequency size would be the size of the array. F0 base oscillator frequency. I don't even know what that. I don't even know if that needs what that is. If it needs editing or what. We're gonna have to do some stuff to tune this at some point. And I don't need blink milliseconds. I don't need flash milliseconds. That was from my invention of the LED blinking engine. I'm going to need a table in order to do that. First, we should just get this thing into some form that I understand. So anyway, let's make a section for variables. And then I need a section for declaratives. Oh, input variables. Those are for octave value from the potentiometer or the CV. CV being control voltage input. That's a -5 to +5 voltage that comes into the synthesizer and tells it what to do. Switch mode, switch octave, LED timer. I'm not going to worry about right now because we're going to reinvent that when we get there. So we don't need input varies. That's a subsection of variables. Declares. I'll just take the whole bouncer into that. And then setup, where we set all the pins. Take that, make the tables, set up PWM, start serial for troubleshooting, and then we do the bouncing. We'll just steal that whole setup because we're not really going to change a lot that's going on here. Button input pull up. I guess that's handled by the debouncer. We'll just get it out of this section. Octave select, mode select, mod in, CV in. Panel LED is an output, audio output is an output. Although I think PWM sets that up. We'll just put that in there for fun. So make the huge tables, table set and octave select. We're gonna get that. Should we get that out of there? I don't know. It's gonna be tough to figure out what exactly I need to get out of this program at this point. So we do all that stuff and then we go into our loop. And our loop is just a list of things. So I'm going to debouncer update at the very beginning of that because that's pretty self-explanatory. We just check to see if anyone's touched the button. And then we do a bunch of stuff. We do the waveform, we read the analog inputs, we have a switch handler, a test LED, and a test prints. We're gonna need to iterate through an LED handler though. And then the button handler, or the debouncer update is what's going to be doing that, but switch handler and button handler. And then the test programs I'm going to comment out, but we will use them eventually too. So we update the debouncer, we do the business of doing the waveform, we read the analog inputs, we handle the switch, and we handle the buttons. Maybe do wave should be at the end of that. It doesn't make much of a difference, but we'll do the wave as the last thing because we'll handle all of our external inputs first. So update the debouncer, read the analog inputs, handle whatever state the switches are in, and then handle whatever the button has done to the rest of the program. And that all happens very, very quickly. So it'll seem like it's all happening at once, basically. And that's all we have for the time being. We'll re-enable test prints later. On PWM wrap is apparently something that we need. So we're going to copy that, and we're going to put that down here in our functions. So on PWM wrap is something that happens when we've enabled this wrap. It's an interrupt when the PWM handler gets through all of its rounds and it's at the end, then this program will run and then it clears the IRQ, sets the frequency. If F is greater than 255, it sets it back to 0. Int K is equal to, I don't know, it just makes an int out of the number and then it gets mod wavetable value of K plus 511 apparently is the the way that it outputs whatever specific part of the PWM has been set. And I think this needs to like have a check in it. If we have like a previous frequency and then our new frequency is different. So this needs, but then again, we're still looking for the wavetable of F, and F, does F get incremented here or not? No, we're not incrementing the frequency. The frequency should be just F at all times. We got to look through that and how this program works. I think right now what I need to do is just clear this. We'll just clear this and look at it later, because that's not part of the framework yet. It's part of the functioning of this program, but so this needs clarification. We're not even going to do on PWM wrap. Okay, so what do we handle first? I mean, we've got all this setup up here that we're not really using. We have table set and octave select that are in here as well. I guess I need to get rid of these. So we'll comment those out. I'll leave them there just so I know that something's happening there. We're going to start in on our variables. So these variables are going to be the things that will set everybody else up. So what are we doing first? Well, first of all, I have it doing reading the analog inputs. So first program, void read analog. And that's going to read all of the analog inputs. So here's where we get and scale inputs. So first things first, what we want to do is we basically want to set a global variable that another program is going to use, right? So another program is going to use and all of these inputs. We need to scale them as well. How do we do that? I mean, we can use mapping functions. We could map them in this, and then the tuning value of that can be used. Or we can multiply it by some kind of a tune so that our 1 volt per octave, because this is 1 volt per octave, it needs to actually be accurate to what we're reading. We need to know that a range from 0 to 1024 actually represents the voltages from -5 to +5 volts. So the question is whether or not I want to tune it in the program or if I want to have like multipliers up above. We'll start with a knob. It all starts with a knob. Well, actually, let's do 1 volt per octave first. Yeah, so 1V per octave. And then the other one's going to be the CV/mod. 1 volt per octave and CV/mod. So the beginning, what we're going to do is we are going to want an output of a global variable. So we're going to do on our variables up here, should it be a float or should it not be a float? It's going to be used for a lot of calculations, so maybe it does need to be a float. I have them as ints because it's 0 to 1024. Float mod wavetable, that's a float table, that's going to be huge. Int frequency in, although float is a frequency. Mod is also a float. But then when we're inputting it, it's just 0 to 1024. It's just there would be a little bit of tuning going on. So do we factor that in? Float. CV mod. Float. 1V. No, I can't do the 1. V per oct. That's not a good one. Zero, zero. So the question is, I only want stuff to happen when these change, but stuff is going to be constantly changing for these. So I don't think I need to check to see if any values are the same as they were previously. We're going to make them both floats for now, although I think at the end of these calculations, they won't come up as a decimal equivalent number. But yeah, so float, CV mod. Goes down here. And then a volt per octave will go here. And I guess what we can do is we've got the 0 to 1024 input values. So we're going to I guess it's going to be an int. So int analog read, and then our pin for this input is mod in and oct vn. Oh, I need to actually give it an int. One sec. I was going to put that there so I can actually mark down what the variables are and memorize them, or well, have them there so I don't need to memorize them. So analog read of mod in. That's all I need for analog read, right? We're going to be looking at Arduino reference quite a bit today, so we might as well just get started with this. Arduino.cc. They made this hard to find. I don't know why they made the reference so hard to find. It's like documentation and then language reference over there. I guess they probably want to get rid of this in lieu of something that you search, but I like having all the functions just right in front of me. It doesn't judge you as much. Yeah, so all we have in the parameters is just the pin, right? Analog to digital converter 0 to 1023 for 10 bits or 0 to 4095 for 12 bits. That'd be kind of nice to have 12 bits. We'd have a little bit more accuracy in our reads, but I guess the RP2040 is set to 10 bits because we've looked at the variable. It is set to 10 bits. .0049 volts per unit. Okay, well, that's pretty good. Okay, so we're analog reading this into a local variable. The local variable is going to just be like read oct or something like that. So we read it, and we take that one in, and then we read knob is equal to analog read of mod knob. What's that one called? I'm breaking this out and I'm making it multiple different things. We could put this in one line of code. It could read both of these and do the math on it all at once, but I'm just trying to make it a little bit more accessible here. So our pot freak and pot octave, top and the bottom, but that's not how that comes out. This is where we get to change all of this stuff. So let's look at what Hajiwo has. Frequency and mod. So it shouldn't be pot freak. Well, pot frequency, that would be the top one. So this one is actually pot freak. And then the bottom one is pot mod. I'll just check the P numbers on the PCB. 27 and 29. 27 being the top one. 29 is the top one. Why was this the opposite? How did I get this so wrong? Frequency and then mod. Oh, this is a bot. How's it going today with the project? We're framing out the code. We're taking everything out of our other codes. This is how I program stuff. I get very easily overwhelmed by the complexity of programs, and when that happens, it's time to start a new one. So I have tons of new ones. We've already done the test where we verify all the hardware that we can get our grubby mitts on works. Now I'm making a framework so that that hardware controls things. Then we can put in the math and make it do the business of making waves. So things have looked a little complicated, but what we're basically trying to do is set up just the bare minimum of functionality out of this thing so that I can then give it the complicated stuff. So what we're doing right now is we're setting up all of the ins and outs, and we're adding them together and scaling them. So I'm going to map these to a 0 to 1024 value, and I guess that can be adjusted in order to tune our inputs properly. Because 1 volt per octave is going to be kind of a sensitive adjustment. So we'll set these up, and then we'll have to make serial prints in order to make them function. So our loop is very simple. Update the bedouncers, the bedazzlers. Update the bedazzlers, and then look at the switches, and then look at the buttons. So read analog, handle the switches, handle the button. And we'll take a look at how to save the mode number in the EEPROM. Do you really need to understand it all on such a deep level in order to use it? No, but I mean, this is the welcome to my stream where we understand stuff on a very deep level. I need to understand it on a deeper level in order to be able to use it. Like not use the VCO. I don't need to understand the VCO on a deep level to use the VCO. I need to understand the software on a deep level so that I can use it elsewhere. So I can make changes on it, and I can turn it into a filter. I can turn it into this and that and the other thing. So the framework is actually going to benefit us in the future for any future sort of things that I wanna put together. That's the wrong one. Any future stuff that I want to put together. So yeah, this is a very necessary venture here. So we read the knob. That's the analog read of the top one or the bottom one. That would be, well, this is 1 volt per octave. So that would be freak in. Is that what we called it? Is that what we called it? Is that really what we called it? No, pot freak. Could have called me in high school. Pot freak. So we've got 0 to 1024 ints. In the old code, they just added them up. So I could actually just do int read. Although we're going to want to scale both of those, right? Because one of them is the octave and the other is the knob. And do we want to scale them like originally so that they go from 0 to 1024? I guess so. So I guess this is where we scale it. In our program right now, we can actually see the values and scale them. I'm conflicted. I don't know whether or not I want the scaling values to be up at the top of the program, in which case there would be 2 variables. One would be multiplicative and the other one would have been additive. So you either multiply or add a tuning value to this thing so that you can fit it properly within the limits of the input. Although scaling it might be all that's necessary, but these are 0 to 1024. I guess we can just put our math in line, because if we scale it initially, then everything will be good to go, I suppose. I don't know about scaling the analog, and then scaling the frequency is a whole nother pot of worms that I don't really know how to get to. Let's plug in USB and just see what the values are that come in and scale them properly. Yeah, so here's our inputs. So we get a mod control voltage, volt per octave control voltage. We get the octave pot and the frequency pot, although it's not really the octave and frequency. So that would be frequency pot of 0. All the way at the other side, 1017. So actually what I can do is scale. I can use map. Analog read mod in from 0 to 1017, and then map it to 0 to 1024. We just use the map function. That'll make it a little easier, right? Oh wait, that's not the control voltage. Of course, we are going to do the same thing to the other one, but we'll use the power supply for that. Yeah, so that'll I guess it'll be a necessary thing to do for any new module that I want to spin up, is I need to go in and just measure these values and then use scalars on it. So we read the octave, the 1 volt per octave input. So let me put our pin over to that, and then I can go to 6 volts. Make sure that's in on the power supply, and then that's 6 volts. Well, right now it's at 0. So our volt per octave CV is currently, it's not at negative. Oh yeah, we need it at -5. So -5, so I reverse the leads and put this up to 5. So now we're at -5, and we are at 1010. That's easy enough. So just put 1010 in here. Actually, wait, our 0 value is technically 1010. This will also reverse it if we do this way. So what I can do now is I can flip the leads and see what the value is on the other side. And then we'll be tuned. 2. And that handles reversing the things because our stuff comes in backwards. Oh, I didn't put map on the other one. So then our volt per octave is going to be, it's going to equal the map of read oct plus read knob from 0 to 2048, then 0 to 1024. You know, that's kind of a sloppy way to do it. We could have done that with we could have done that in binary numbers too, because those divisions are really easy to do. You just take the most significant bits, right? You could do that a lot easier and faster without having the program go and do stuff like go and do math. You could just do bitwise operators in order to solve that. But you know, this makes it a little clearer, and we can see all the mappings here and adjust appropriately. So mod input. So it's the same exact thing, only we're going to make some slightly different sounding variables. And then this gets the same exact treatment too. You could almost make a function for something like this. These values are floats, but that's because they're going to later go into a different equation, right? Did I say canine cop somewhere? Yeah, wasn't that, it was, that's not the, well, there's Turner and Hooch, but I think there were like 1,000 movies that wanted to be Turner and Hooch back when we were all kids. It was all VHS, just garbage. They were just shoveling garbage onto VHS. And so there's about 1,000 kids movies with, you know, boy and dog solve crimes, boy and dog play basketball, boy and dog do, you know, just about everything. I really need to get my hair cut. This is getting a little ridiculous. I'm like I'm looking at my picture over there, and I'm like, wait, what is this? What is that doing there? Okay, there we go. Jeez, stupid. Okay, so read CV. Well, this would be read mod. Read mod. I'm doing this in the you know, very sloppy way. Read F knob. Read F knob, and then this one would be read C knob, or read M knob. Read mod, read M knob. What's up, Make Mistakes? How you doing? We're doing okay. We're doing okay. So read mod, read M knob. And now we need to get these values. So we're going to take the mod knob. That would be this one. So there's octopot, you can see changing. 0 to 1. That's a pretty strong 0 there. So that one is 0. And then our top value for that one. I'll have to set up this program so it still can output these values so I can use this in future programs. 1018. So we map that from 0 to 1024, which isn't going to make that much of a difference. Where are the dogs today? It was well over 10 years ago that they were doing that. So yes, you can safely assume those dogs may not be around anymore. Sorry to break it to you. So read a knob. Oh wait, that was the wrong one. We just did the knob. We didn't do the... That was the mod CV. So actually just transfer the numbers over. Wait. Oh, this is the wrong one. No, pot frequency, but why is that backwards? That's not the one that should be back. I messed up. I messed up this part. I did something wrong. I just need to reverse these. Read oct. So read m knob, and then read mod. Okay, that solves that. Okay, so the knob goes from 0 to 1018, and we're mapping it to 0 to 1024. Not that big of a deal, not that big of a difference, but we now know that we can access the full range. Since we're adding them both together, I wanted to put them back on like a number line style thing, where, well, but then you don't reach your maximum value unless they're both at full. That doesn't work. Because you would need the full value of both of them in order to reach the maximum value, which is not how it should work. How should it work, though? Because if I do them added together and then I put them on the same number line, or if I scale them, we got to look at how other people are treating these knobs. I got to figure out how this works. Because I would assume that you would have like positive and negative influence on the CV coming in, and if there's no CV coming in, you still have the same positive negative influence on a number that's in the middle of the number line. So you can add or subtract the same amount to it, and you can get to double that number or negative double the number. Oh, man, I don't know. I do not know. It should technically be at 0 when it's in the middle, right? Because that would have 0 influence. Okay, well, let's get our CV input scaled first, just so that I have that value. That's going to change from synthesizer to synthesizer, and we're not really supposed to be doing scaling right now, but I figure it'll just be fun to do while we're here. So that's positive 5 volts, and then mod CV is 1. So it's to 1, and then we make it negative 5 volts, and you'll see that mod CV change. Negative 4.996 is 1013, 1014. So let's make that 1014, and then it's mapped. So we've mapped the value. So my question is how they handle this. We have, I guess we have access to Mutables Instruments code, which is doing similar stuff. I mean, we use some of their circuits. So Mutable Instruments. Let's take a look at Mutable Instruments documentation. Any of these are probably good. I think one of the ones that would be the newer ones would be a good idea. 2015, 2016, 2021. Let's take a look at beads. Beads takes a bunch of control voltages in. This is not the proper page, though. We're looking for an actual, like, we're looking for the code. Yeah, the site was closed. Everybody's like, rip. What it? I guess the original, oh, here we go. Yeah, there we go. Okay, so beads. And then we want the, oh, there's no open source on beads. All right, so what's a newer one then? It's because I'm so zoomed in. Yeah, there we go. 2022, blades. No, there's only hardware design. We don't have software in here. Blades is unfortunately dead to me. Veils. It's sad we're not going to be able to access as much Mutable Instruments stuff. Beads, like anal beads. We're looking up Veils, open source, GitHub. Only hardware design? Yikes. Streams? This is tough. All right, is all the software just gone? I know people have archived it, but source, GitHub. Okay, here we've got some stuff going on. CV scaler, envelope, filter controller, follower, gain, Lorenz generator. Man, this is some crazy stuff. So CV scaler, let's take a look at that. Free of charge for any person obtaining a copy of the software associated with documentation files, the software to deal with the software without restriction, including without limitation of the rights to use, copy, modify, merge, publish, distribute, blah, 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 blah. The above copyright notice, this permission notice shall be included, blah, 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 blah. I just want to see what they're doing to the numbers. Excite offset, audio offset, DAC offset. That's a little calibration storage load. K default offset. Shift with a binary shift. God damn these STM32 programs. Can calibrate. It's creating a what? Constant? What the hell? Do not calibrate when it looks like the user's doing something stupid. What? Wait a minute, what? CC 3 times I plus J. This might be like an auto calibration thing that you go through, where you hit a button and it does the thing. I'm just wondering how they take the knob versus the CV, right? Frequency offset, frequency amount. Hey, stop doing that. Audio, excite, gain, frequency. Configure int32 amount parameters of 1. Amount is equal to negative 37. The negative equals, I don't know, what does that do? I forget now. Does it just opposite it? Amount is equal to amount shifted. Amount times amount. So you double it and then shift it 15? I guess it's a 30. What? That doesn't make sense. I am not going to be able to understand this, am I? We're going to end up fleeing with our tail between our legs, just doing exactly what Hajiwo does, which is kind of what I'm setting up right now, is just adding the two together. So if one is in the middle and I move the knob all the way down to 0, I'm not doing anything. If I move the knob all the way up to the top value, it's doubling the values. So they just basically, they just both max out very easily. Unless you set one all the way to 0. How do we do this? Nah. This is more like a modular synth kind of thing. And I don't really know what to do here. I can continue doing it this way because this is essentially what Hajiwo was doing. If we look at his code, we look at the Hajiwo code. It's somewhere in here, isn't it? No, this is all the other research stuff. Where's it? There's another window. Sir, another window. Okay, there we go. Let's look at this window, and then here we've got all of this stuff. And then down here, we have the Arduino code. So what we're doing in order to read the knob in Hajiwo's code is, there's our loop, push switch, digital read. This is for the switches. That sets the octave. This one sets the mode, what is it? The carrier mode or whatever. The modulation mode. There we go. So then analog read 26 times calibration. Then we constrain that to 1225. Oh, I see. So we're constraining our input to 1225 for the, Well, but okay, frequency pot and then oscillator frequency, and then we have mode 1, 3, and 2 for the switches. And then we have the push switch. So what are we doing here? We're constraining it to 1225. I guess I could do that here, or I could do that when I should probably do that when we calculate it later on. So for the input, it's going to be 0 to 1024, but then we're going to scale it later on to 1225. But this one is just reading analog read of 26 multiplied by a calibration, which we're using a map. Probably ends up being the same thing. So the oscillation frequency, they're taking the frequency table value of the ADC, which is restricted to 1225, plus the value of the frequency pot. The value of the frequency pot is an analog read of pin 27 mapped from 0 to 1023 to 0 to 127. Okay, so this is where things are getting a little... Okay, I didn't reference this before, but maybe this is what we should do here. So 0 to 1023, 0 to 127. I'm just going to put 1024 in there because I don't think it'll blow up if I do it wrong. But this one is 1225, and then our frequency pot can only do a very small amount of adjustment on that. So actually what we want to do is we want to take the frequency knob and we want to map it to 0 to 127. I don't like having the numbers in here, but I guess that's just what we're going to do. 256 times oscillation frequency over 12270 times 1 plus octave switch value. Huh. So maybe we need to actually just output an oscillation frequency instead of having this stuff go out to globals. But it would be better, I would much rather have these calculations elsewhere instead of, like, where we read the pot, we get out the value, and then we can report that with a serial print, and then I can take that in the calculation stuff. So yeah, I'm going to get rid of, this one's going to be 1024. So that the full range of all of our inputs are utilized. But then this stuff is not going to happen here. So we're not going to output one value, so we're not going to declare it there. We're going to make them global variables, since we're going to serial print them. This is the logic that I went through before. I'm just doing this on air now. Poop into globals. Globals. And those will be integers. These we don't have anymore. And then we don't need this explanation. Don't need this. Oh wait, yes we do. Boop. These are analogs, and then we don't need the map functions, and we don't need... Actually, all we need is these names. We'll start them off at 0. Actually, probably 512. We'll just put them in the middle. They'll immediately get overwritten, so... This is just making sure that none of our math breaks if things are weird. Although they are getting mapped from 0 to, so I guess they would be valid if they were at 0. It's just I don't know what the equations would do to our variables. Yeah, I guess we just have to plug them into globals. And they can get printed out and be on a scale of 0 to 1024. Yeah, that's how it's got to be. Read mod, read m knob. Read mod CV, read mod knob. And I guess we'll get rid of read on this. So mod knob and mod CV. And then freak. I know I'm renaming everything, but it's just... Freak knob, freak CV. freak mod freak CV. That Q is hard to get to. Should be capital C, lowercase v, yeah. CC, CV. And then mod. Oh, freak knob. Whoopsies. That's what happens when you get coded for a couple days. Frequency. No. Mod knob. Jeez. Mod CV. There. Okay, cool. Now we've got global variables that we're putting our analogs into. So when we read analog, we do that. Then we have to make a frequency out of it, I guess. And that will involve more stuff than just this, I believe. Well, we're doing, what are we doing here? We're reading that, and then we're doing, that's mode. Where are we dealing with our other inputs? Because we've got our analog read of 27, our analog read of 26. That's the pot, and then that's the ADC. And there's two more analogs that we need to deal with. Did I read it? Don't you worry about the individual little tiny mistakes that I make. They'll all come out in the wash. Oh yeah, you guys are being I'm not even looking at chat for that stuff. Come on, you guys saw me. I got them. I corrected them. It'll all come out in the wash. So for that one, that would be the frequency. So I guess when I do this, I could make the frequency. So here, I should probably have it seems like maybe I should have a different program doing this, but make freak. Yeah, we'll have a different program doing it. I'll just have a different function do it, just because it makes a little bit more sense. So read analog and then make freak. So make freak, that'll be another void. Make freak. Now we should have been framing this whole thing out. I'm just trying to figure out where our numbers are going and how they're added together and stuff. But this does the business of creating the frequency. So it would be oscillation frequency is equal to 256 times blah, 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 right? So what we'll do is we will take the same logic as Hajiwo. Hajiwo. And we will do our freak knob. We won't overwrite that, so we'll make a new int. So integer knobbed is equal to the map of freak knob from 0 to 120. Well, 0 to 1024 from 0 to 127. You guys want to correct all the syntax there? You guys want to tell me to put a parentheses on there and maybe a semicolon? Just go ahead. Just tell me to do it. All right, I'll do it anyway. So that is our new int. That's the 127 frequency value. So that would be, oh, ADC constrain. So that's for the knob. So freak knob. But then for the ADC, we're going to do, I guess, another int. Freak int cv'd int v scaled or something like that is equal to the map of freak cv from 0 to 1024 to 0 2, and then we have a define in here. We have a frequency. Well, that's octave resolution. What's this one? 1225. Why is that 1225 there? I don't have 1225 anywhere else. I got 1230, not 1225. Define well, oct, what would this be even? Used in the scaling, or in the, no, freak knob, no, freak C. 1225 plus 127, is that what we're doing? That's not the calculator. I need a calculator, it's too many numbers for me to do while on air. That doesn't make any sense. All right, get out of my face. 1352. Yeah, I don't know. It's strange. It's, I mean, this is how he's doing it, so whatever. What I call that? I call that oct scale or something. Yeah, oct scale. It's, we're taking that and then we're remapping it from 0 to a weird number. Confusing. 1225. So the frequency pod is mapped to 127. We already have that. And then octave frequencies, 256 times oscillator frequency over 12270. What are you setting osc frequency as? It's probably a float, isn't it? Osc freak. Float. Yep. Because you are floating. Float osc freak. I just leave junk data in there. Oh wait, I don't, do I need that? Yeah, I do. Ah, whatever, let's just make it. Actually, I don't know what the range of this number would be. We'll set it to 0, I guess, because before we output anything, we'll at least go through and calculate it. So then that would be osc freak is equal to, and then we've got this equation here. I'm not going to see whether or not I have variables in any of these positions that could later be adjusted. Where in the hell are we? We're all the way up here. This code is crazy. 256 times osc frequency over blah, 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 blah. Copy. Put that in here. So 256 times, oh, there was already an oscillator frequency in here. Oh, it's from the frequency table. Freak table, ADC plus frequency pot, huh? Oh, but wait a minute. We generate that from an equation in the redo of the code because we don't have a frequency table. We don't need it. Or no, we make the frequency table from the get-go. We just do it by equation instead of having a huge value table like this thing in there. Because this is actually a set number of values. Frequency table 2048. So we need to make the frequency table, and that's what the table set variable is doing. This is helping me understand how this code works. Because this code is cray-cray, and it's hard to follow. So we need a frequency table to call upon for make freak. So what I need to do is set up the part of the program that's going to make that frequency table. And we have that here in table set. So table set's all the way down here. Test LED, button handlers, read analog, do WAV, table set. I don't need this for the framework. I said I'd do a framework and I ended up reading through the code. That's PWM wrap, and then this one is table set. That's just going to make wavetable of I. What? Wait a minute. Wavetable of I, but then where's the frequency? Which one is frequency table? That's VoctPow. Frequency table of 2048. Frequency table is, where does that come from? Oh my God. Voct_pow of I. What the f... This is a whole bunch of stuff. But wait a minute. This is okay, I'm starting to lose my mind here. So 2 to the Voct_pow, and we're multiplying F0 by that in our setup? What? And that's setting the frequency table, and then everything above 1230 is set to equal to 6. Frequency table, ADC plus frequency pot. Come down here, we'll just look to see if it's used anywhere else. It's not used anywhere else. And it doesn't look like it's dynamic, it's just the value gets referenced from here. So we need to make this once. Where else is F0 being used? But this is in setup, so I mean F0 base oscillator frequency is being set with the number 35. So it seems like if we're doing all of this like variable math, we shouldn't be doing variable math in setup. And if we're setting up a big table that we're going to be referencing elsewhere, okay, let's see here. We could just make this table instead of Voct_pow. Where else is Voct_pow used? 1 there, and then anywhere else? No, Voct_pow is not used anywhere else. As there are only 2 instances of the word on this page. So why even have this giant array if you're immediately, and by the way, this array can be calculated, but then you're immediately going to be calculating it away based on the oscillator frequency. So in table set, we actually have a lot more to do than this. Sine 2 pi I 256, and that's wavetable of I, but I mean wavetable, have we even set that up yet? I don't even have that variable yet. So I'm going to need float frequency table 2048 in here. So frequency table 2048 values, and then we're going to need a 35, so that's F0's base oscillator frequency. I don't even know if our oscillator frequency's base is 35. That might change later on. I don't know. Scale 1024. Okay, so we can make a big equation that's going to do this during table set. And it doesn't do it based on the mode. The mode doesn't change it at all. It's just that this constant static float is always in there. And then depending on the values of some of these things that don't change anywhere else, F0 does not change anywhere else. There's only 2 instances of F0 in this entire code. And one of them does not reprogram F0, it runs during setup. Crazy town. Oh, table set is a different function. This is octave select. Well, I'm putting it in table set too. I guess table set is the one that was converted into an equation. Where's table set? Table set. If mode is equal to blah, blah, blah. Okay, so that's actually a much different... That sets up the wave table. Depending on mode, but then when does it get... It has to be recalled. Waveform, push switch, mode. Like in our main loop, right? Here's the loop. We come down here, push switch, blah, 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 mode, frequency, mod, waveform. If mode is equal to 0, mode is equal to 2, or mode is equal to 2, table set. If waveform greater than 7, what the fuck? Push switch, digital read, etc. So table set is going to need to be called elsewhere. What is table set? Table set does the business of all this stuff. So our table set is not named the right thing. Maybe call it table setup. Table setup. Different program. Table setup is doing something different. And that's creating the wave table. Oh no, that's right. Okay, so I took that out and made it just make a sine wave for that other program. That's what's running right now. It's just making a sine wave. Okay, I get what I'm doing now, sort of. So table setup, we need to make the wave table and stuff. Okay, now I understand. I got confused. So during that setup, what are we doing? We're octave select. That's a different octave select. That's not what we're doing. That's in the loop. This one is octave select here. I to 1230 frequency table equals F0 power voct pow of I. And voct pow can actually be set up via equation, and the equation is over here. I think. Wait, it's over here. Do the WAV. Wavetable I mod, that's different. Read analog, switch handler, button handler, blinking stuff that I was trying to get together. Test the LED, print out the serial stuff. What happened to creating this table? Set chain level. Huh, it's in a different piece of software. I guess it got lost to time. It's any wonder this program worked in the first place. Frequency table I plus octave resolution equals number of octs. How does that even work? Yeah, here's the octave select. I guess this is the rewrite of... Let's compare this to the other code because I'm getting confused. So it's between that and the original code, which has it look like this, which is very similar looking. So let's see. Frequency table of I, that's for 0 to the resolution and then the size. So I've replaced these variables. That might be also still wrong. It is any wonder that this code worked at all in the first place. As far as the number of octaves, that's all correct. Although I don't know about the direction of this. I guess from I plus 1230 from these values, for the range of these values. Frequency size, octave reservoirs, resolution rather, I keep saying reservoir. 1230, so it's 2048 minus 1230, 2048 minus 1230, I plus plus, and then 0 to 1230, which is the octave resolution. We I plus plus through that, and we set frequency table equals to F0, which is 35, times power of 2 times number of octaves times octave resolution. But here it's voct pow of I. This is incorrect. Oh, number of octaves times I over the octave resolution. Wait a minute. Is that what voct pow boils down to? What the heck? I thought I had an equation that made that whole thing. So somewhere in, I think, my code, it should be making voct pow of I. And this is voct power, but it's just those numbers over one another, which I think avoids having to do all of that 1225 math. Yeah, I'm trying to make heads or tails of what the heck's going on. It's a tough process. I'm trying to tell you guys everything that I'm thinking of here. I think I need to open an older piece of code in order to get some of that stuff that I might have lost. I know one of y'all suggested this in a previous stream, but where did that salt? Oh yeah, that's right. It was in the wrong folder. Somewhere in here. Just gotta wait. Arduino's a little slow. This is an old version. Right, no activity when I do software streams, huh? You guys used to be locked in on these things. $10-bit wavetable, 256 wavetable resolution. So, oh my god. Oh yeah, I was trying to set up mode lists, wasn't I? That's a little different, but table set and then octave select. So octave select does, yeah, 6i times 1230, because that wavetable is so, like, it was linear wavetable. Sing us a C++ shanty. Oh, gone are the days of function nodes. I don't know shanties. You're a shanty. For I is equal to 0 to 2048, 1236. I guess that's what it is. That select octave is just our table setting thing. And we've reduced significantly the amount of weird stuff that needs to happen. But that means that we're not doing table set. Table set handles all of the stuff. It does the business of doing all the equations based on the mode. Table set does equations based on mode, and if we call it up twice, that means that I have to have it in a state to be called at the beginning. This isn't framing this out at all. I completely lost track of what we were going to be doing today. Wait a minute. I got bamboozled. I guess I could just do oct select there. Where else is this frequency? This frequency tables gets called on elsewhere, but it's just in the setup, so it only runs once. I gotta go back to Hajiwa's code. That's not it. If you guys want to see what the wavetables are actually, or the functions are actually doing, the FM modulation, let's close this whole thing. Oh wait, cancel. No. This is it. Ben Gizmo made this wonderful thing that helps you understand what exactly is going on. The people watching on YouTube have the link already. It's in the description. But this is Ben Gizmo's little display of what the wavefolding tables do. The FM modulated wavefolding, all those polynomials, when you give them a mod from 0 to 127, this is what they do to the base wave. So you can activate them over here, and then you can run the mod on them, and it makes your waves a little wooblier. You can scroll in and out too. Look at him go. That little guy right there. Beautiful. Yeah, but that mod value, I guess, plays in 0 to 128. It plays into what the equations are doing to the various sine wavy kind of stuff. They make it nice and dirty. Look at how dirty that is. Wobulator visualizer. Okay, yeah, I am kind of losing sight. So this sets up frequency table at octave scale, but is that, yeah, like once? So this would be calculating frequency table. That's basically what it's doing. Puts sixes in all the upper positions. So calculates the wavetable value, and then it does a bunch of other stuff. But then table set sets a wavetable based on mode and waveform. So this would be a big, very large thing to run, right? Yeah, isn't that pretty cool? It's like a nice little visualization. We don't really need table set to do anything right now, but I mean, we do need it in our main code. But then I guess when we read the mode, we set the table. Wave table of I is equal to sine 2 m pi over 256 times 511. Oh yeah, this is just a singular. That's just a singular mode. So in our framework, we don't need it. So right now, we're just going to leave this alone. Logic here to do nothing if nothing changes. Because I don't want every single cycle to be writing a new wave table. I want it to be able to, like, if I take a step back and nothing is in kind of a state that changes it between one thing and another, I don't want it to write an entire new wave table based on that. And when you go into the different modes, it will then create the tables that it uses. And my only problem is 0 to 256. It's like making 256 entries sometimes every single loop. It's just a strange thing that's going on with the software. Okay, so if we've got all that stuff, we're going to break out from this and do less calculating stuff. We'll get rid of do wav because that's based on, yeah, get rid of this. Poop fart. Sets the output. So what is, well, what was I doing before? Hold on. Yeah, sets mod 2 wavetable. Wavetable that PWM outputs based on mod mode and mode. Well, you don't put folders on your desktop? You think you're better than me? So this is like mode switch sets modulation, mode button sets modes of modulation. Not confusing. Okay. We don't need that yet. We don't even have the ability to have that do anything yet. So what we've done is we've read in our analogs and we've scaled them and we've created some of the stuff that it's going to create. The switch handler, I have it reading in the switches and just setting the mode select. Now, mode select is meant to go into like an equation, like the mod. You would flip the octave up and down, and it would be able to multiply stuff differently. I guess well, I don't know if I want to leave it the way it is or what. If I set, the problem is there's no correlation between the binary inputs. Like if I could convert the binary inputs and somehow set it to be a specific thing, I just put them into the bits of a UNT and then set that equal to whatever the octave or mode switch variable is. So if I did that, 1 1 would equal 0. I guess if I took the opposites, because there's, okay, so where's the octave switch stuff? That's not in this. This one is our framework. Wait a minute, where have I been coding to? Oh, this is our test program. Did I do anything in the test program? Oh, yes, I did. Uh-oh. Uh-oh, I've done some stuff that I shouldn't have done. I have been editing the wrong thing. So table setup and octave select. Well, table setup would be just a table set. Oct select I'm going to call table setup from now on. And then we can leave this like that. This sucks. I totally I can't save this when I close it. Put table setup here. So table setup and then table set. This is so confusing. Sorry about this, chat. Do the business of wave. So make the frequency, that's the knobs. Read analog, that's the knobs. Table set, that's the logic. That one gets called on to do different modes. So I guess do the waveform stuff should go, I guess, somewhere else. Well, that's after table set. Yeah, table sets first, and then we do the waveform business. It's gonna be a weird program. It's gonna be a weird program. Hopefully I can like smash things together and make them look all right. Like once we get a function for that polynomial thing, then our modes will be a little bit more simple. It'll just be a big block of code that has all the inline functions in it. Maybe a switch case that's kind of like crashed together, which I've seen. I've seen a switch case that's been minimized, and it's kind of cool. So what have we done so far? Let's see. Debouncer update. We read the analog. Well, actually, from the very beginning, what we do is we table set and then we table setup, and that makes the octave frequency. So table set sets the thingy-majigs based on the mode. Table set's going to have to get called again, probably in the button handler. What does table set rely on in the original code? Probably quite a few things, to be honest. Because down here we've got, let's see, octave select. See, there's another octave select, but this one's based on a switch. Very strange. That would just be all in the switch handler. Then we do our frequency calculation. Every single loop we do a frequency calculation. Crazy. Mod setup, which is constrained. We haven't gotten to this yet. Those are the other. See, this one is based on mode, so that's where things get a little hinky. Push switch, and old push switch, blah 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 blah. Void loop. This would be a different loop, but and then mode is equal to 0, wave fold, mode is equal to 1, FM. Are we running table set anywhere else? We do all this business, unless the mode is equal to 2, or right there. Okay, void. Wait, this is the void table set. It's just not indented properly. Where's the end of this? Oh God, this is so annoying. Are they declaring a function only inside of a loop? What the? No, because then you'd have to be able to get to it from setup. Mode is equal to 2, do that stuff. Mode is equal to 0, do that stuff. Here's this one. I don't think this one highlights the opposing one, does it? No. Probably should put this in a window. Let's put this in an Arduino window. Oh wait, that copied way too much. I copied everything. That's everything. I think we already have this code somewhere, but I'm just gonna do this to hunt parentheses. So copy that, and then we'll go to just make a new that I'm not gonna save. I'm so lost. This code is just the maximally confusing, weirdly set up kind of code. What we need to do is just do the framework. I'm just trying to read this just for academic purposes, just to figure out when the stuff is happening that we need to have happen. So here it's not indented. That's a little bit easier to follow. So this is actually its own function. This ends way down here. Yeah, okay. And this is based on mode is equal to 2, mode is equal to 1. The switch is the waveform. The waveform is the button number. Case 1, 2, 3, 4, 5, 6, 7. And then this one is if mode is equal to 0, and then we have different. This assigns them, I guess, like this is wave folding or something. I don't know, man. Okay, whatever. Moving up. This one is mode is equal to 1 FM. These are big sine wave equations. But there's more of them down here too. Amplitude modulated. What? Non-integers, multiples of FM1. There is just so much to this code. It's crazy. Yeah, this one has different polynomials. Huh. FM modulation is the one that Ben Gizmo worked on. But then these are very similar down here. Two mpi times 11 times I to... Jeez! This is why I need a function for this. I just need a function that takes in the polynomials and defaults them to off. Good lord. Good god, yeah. Mod wavetable of I is equal to wavetable of I times mod. Cool, 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 okay. Mode is equal to 0, wave folding mode. For this, for that range, for this range, for that range. And I guess that can allow the wavetable to wrap around. Mod parameter set, frequency calculation. Based on the analog read of the inputs. Okay. This is a mess. This is a mess. I don't know what I'm doing. Mode is equal to 1. Mode is equal to 2. And then table set is its own thing based on mode. Where else is table set being called upon? It's called upon initially. Let's just search it. So during setup, we set the wavetable, or during the push switch read, if the mode switch is equal to 0 or 2. So if it's equal to 0 or 2, that would mean, wait, it can't equal 0. What's setting our mode? Push switch is equal to digitally 0. If that's set, then waveform plus plus. So we go to the next waveform. If mode is 0 or 2, pushing the push button, well, it would already do this. The if statement is if the push button has been set and mode is equal to 0 or 2, then we're going to set a new table, but only 0 or 2. Why? Why? Why are we doing this? Why are we doing this silly thing? Mode is equal to 1 is FM. Oh, I see. If mode is equal to 0, we're in wavefold mode. And in wavefold mode, we table set. And in mode 2, we amplitude modulate. And if we change waveforms, then we need to set the table. Okay, I think I'm starting to get there. I'm starting to get there. We need to load mode from the EEPROM too. That's one thing. Well, no, we don't load mode for the EEPROM. We load that from the switch. So in amplitude and, okay. So when we read the switch, those are going to be position 0 and 1 of that. So if SW is equal to, and then that's going to be, if I flip the switch, I mean, we could just look at the variable actually right now. We could just look at the variable. Here it is. Mode switch is equal to 3 when it's in the middle. Oops. 2, 3, and 1. So when we are in modes, and it's wavefold FM AM. So 2 and 1. Or W is equal to 1. SW mode. I could call upon SW at this point, but we'll go ahead and do that here. So 2 and 1, then we run. Actually, when does that run? Okay, table set. Oh, that's if the switch is pushed. So yeah, we should do the same logic and do that when the debouncer falls. So if mode is number of modes equal to 0, if switch mode is a 2 or 1, then we table set. Double check that with the original. Make the wavetable, table set, set wavetable. That's our number 2 instance. Where did my search window go? This is just going to be one of those days, isn't it? And there's the only time it gets evoked is when the push button switch gets hit. If the mode is equal to either of these, then we need to make a new wavetable. Otherwise, we simply change the waveform. So I guess we'll keep that variable name. So waveform goes all the way up here, I suppose. Waveform is equal to 0, and then we're going to have load waveform from EPROM. And that needs to be before we do table set and octave select. Load waveform from EPROM. We've done that before. We've done that before with the RC car stuff where we save settings and stuff. I don't know if we need to be super careful about like writing to a different variable every time because we only get 127,000 like writes until the EPROM goes bad. You can always have it like iterate the address and do all kinds of weird stuff like that. The EPROM code is a little bit weird and confusing. What you want to do is basically like read and verify that things are okay. So it's this whole thing that you need to do, but I think we can copy it from either the RC car code or actually from the Erica Synths code, because we reverse engineered an entire Erica Synths piece of software because I thought Julian blew up the software on his, and he did. And so I got a new AT-Tiny microcontroller, put that in there, and I tried, I didn't think to read the hex file from the other module that he had 2 reverb modules. I think he has none now. I think he sold both of them. But we almost fully reverse engineered that software because it's a very simple software. All it did was, one thing it did was send a clock to another module. But it basically set a couple inputs and outputs in order to control a reverb ASIC. It's a chip that just does reverb for you. It's a beautiful little chip. But I made all that code and I made it read the selected program because it read in a button, and it's basically doing exactly what we're doing here. But in order to do that, I just had it use the EPROM. So whatever we did for Erica Synths. Okay, so boy, I wish this PWM stuff was a little bit easier. I mean, I should probably do like PWM setup. That just kind of makes our initial setup much easier to look at. So we'll put it all the way at the top of our functions here. So that's on PWM wrap, and I guess I can put that void PWM setup. Let's put that in there just so it's easier to read through our loops. I hit save and now the whole program is pausing. Yeah, so we do a table set just because. I guess I don't know why we would do it there if the mode is wrong, but anyway, we select our octave. So octave select only happens once though. That's so weird. What exactly is octave select doing? Now that we know what table set does, table set just takes in the mode, and actually we should look at table set too. God damn it. All right, table set. Let's take an actual look at table set. Now that we know when it's invoked, it's only invoked during those 2 modes when the button changes. Switch mode squad. Mode is equal to 0, 1, or 2. Waveform is the switch with all the cases, and then it makes the wavetable. So what does this do? Uses mode and waveform. Mode and waveform, and then it creates the whole thing in the wavetable. And it's doing this with calculations, and it's not using any other variables. It's just mode and waveform down here. Huh. It's not doing anything with octaves. It's not doing anything like that. It just uses mode and waveform. Only. So when we hit the button, I'm gonna have to reorganize these. Yeah, our switch just makes those. Our button reads the switch, and if it's equal to certain values, it'll create that. And then the LED blink was the code that I was working on before that didn't really work. Mode plus plus, if mode is equal to number of modes, then it wraps back around. Oh, and that's if debouncer fell, so... So yeah, if the switch did its thing, then go at it, and if it's above a certain number of modes, we can set it back to 0. They can do that late because table set doesn't need the mode variable. Wait a minute, yes it does. Yes it does. What have we done? I guess we can do mode plus plus, and then immediately following the mode plus plus, we can do the business of setting it. Wait, that was the wrong one. We'll just immediately do the business of setting it back so that it doesn't overwrap. Because table set will not take the number 8. It will reject it. Oh my goodness. How are we going to get through this today? My brain is already soup. I guess we'll keep soldering on. I don't have any liquids. All right, I will go liquidless. I will soldier on. My butt hurts. So this is where, so mode plus plus, then we check to see if it's 0, then we store it in the EEPROM, then if switch mode is 2 or 1, we set the table, and then after all that's done, we blink the LED. We blink LED. And LED I want to set up as an engine. I need to set up a table of values that will take a timing and basically wait for that amount of timing before changing the state of the LED. And so you would have to put in an even number of timings. Otherwise, if you just put one in, it'll just like invert the LED for all the other functions. But then we need to figure out how to make it respond with the tables, I guess. Well, then if it's... Well, it can blink based on mode number, I suppose. Yeah, that's what we could do. It can blink based on mode number. So it would have to... Well, no, that function would better be in table set. That would be better in table set, because table set's only invoked when the button state changes, so. Yeah, and here's the beginnings of my button engine, but it's not quite there yet. And I guess I had 2 functions, and I shouldn't probably have 2 functions. I should just have 1. But the LED handler needs to run each loop, so one adds entries and the other handles the incrementation. We'll work on that in a minute. Wait, this is the test program. I've been editing the test program again. God damn it. What am I doing? I'm screwing it all up. I keep editing the wrong program. Well, let's take let's copy the button handler. This one is the OG code. I'm going to put that all the way over here. We're still referencing it, but this one is the one that I should be editing. God damn it. All right, so button handler down here. Oh, that means I got to go through the whole thing again. Yeah, and then I need to make the PWM thing. This code is ruined because I've messed with it too much. It might actually still work, but it's still in kind of a weird test setup state. all the way down here and grab PWM. So I can't believe I keep editing the wrong program. It's like I need different themes on all the different windows just so that I'm not an idiot. And I'm supposed to be responsible enough to compile my own insulin pump software. How's that gonna work? Maybe I should have done that on stream. I wouldn't have messed it up less. Where's the PWM stuff? It's all the way up here. Probably should put that one at the bottom because I don't ever need to look at it. Setup functions. We can take on PWM wrap is not a setup function. Table setup, I guess that is a setup function. That's choose octaves. So we'll put these two all the way down here. That's not what this one's doing. Calculates the frequency table. It's weird that it has setup octave and it doesn't really rely on any variables. It's strange. Okay, going back up, we have do wave, should be the bottom one. That's not in a setup though. That's the last thing that this thing does, is it outputs a wave. Mode switch sets modulation, mode button sets modes of modulation. The button handler has table set in it. What else did I screw with? What else did I mess up? Did I do anything to read analog? I don't think I did. No, this is the unedited. Yeah, so the other one is what I want. Switch handler is the same as it was before. And then mode is equal to 2 and 1. 2 and 1. Store mode table set. Okay, cool. We're doing well. We're doing okay. The LED blink stuff I'm gonna have to come like recode. Might as well take the test prints. Take all these. Bring them into just a test function section. Test funcs. Let's see, mod CV, V octave CV, octave pot, frequency pot, mode switch, and then octave switch. Yeah, okay, that's good. Debouncer, read button, bouncer. Okay, cool. We're doing okay. I'm not doing okay, but we're doing okay. Are not doing well. Let's see, test LED, we don't even need. Let's see, the switch handler doesn't do anything to the button. The switch handler, what is that one doing though? Button handler. If debouncer fell, mode plus plus. Waveform plus plus. Waveform plus plus. Mode is not that anymore. Waveform. Mode is apparently like a protected thing, although I think you could still use it. Waveform, waveform, waveform. Okay. And then up here we have int waveform. We don't. God damn it. I put int waveform all the way on this one. Huh? Did I? Yeah, I put int waveform on the wrong one. Analog frequency knob, frequency CV, mod knob, mod CV, frequency switch, and so int freak SW int well, it'd be modulation. Freak switch, mod switch, we'll just set them to 0 because they'll be overwritten with whatever the actual position of the switch is in no time. and then int waveform is equal to zero, and that'll get overwritten by something down here, which we need to make a note for. So make the big table. So we do set the pins, make the table, set up PWM stuff, and then we start serial, set up the debouncer, and this would be, I guess, indicate done setup. So before we're done setup, then we're going to want to, not that, we're going to want to read in waveform. EEPROM shiz. Okay, so that's where EEPROM stuff goes. Save that. Having a bunch of windows with code in it is something that happens when I code like this, and oh man, not a lot of viewers today, huh? There's nobody here. That's okay. We're doing a coding stream. It's a little bit more cerebral, and it's also Tuesday, so I figure people are probably busy. We need to go back and do like actual cool electronic stuff, because that'll get me people who actually follow along. And part of the whole thing with doing the VODs to YouTube and everything is that I should be gaining more viewers, and it seems like we hooked a couple people initially on YouTube, but they're gone. Everybody's gone. They're all dead. I don't think people are busy this time of year as an excuse anymore. So when we finally get into our loop, we've set everything up, we've read our waveform where it was selected last time, our 0 to 7, and we're ready to go. We're ready to start doing the business of this code. However, we still don't, I mean, we have a button incrementer. We don't know what to do with the LED yet. So we've got the EEPROM and the LED to set up now. So we could probably pretty quickly do the EEPROM stuff. If I open the, not Ornaments and Crimes, not VCO. Let's see if we can open up that other EEPROM program. And actually, let me, we'll keep Hajiwo's code up, and I'll put it all the way over in this window. And I'll close the test program, because there's a lot of confusing stuff that we're gonna have to go through. Did we get all that slice stuff? We didn't. That's all to do with PWM stuff. Variables, analogs. This would be inputs. This would be modes and settings. Or no, well, modes. Frequency stuff. And then we've got PWM stuff. So that's going to do slice number K and F are all used for PWM stuff. Wavetable, mod 2 wavetable. And then the frequency table. Well, those are all frequency related, so I guess I can put them in here. The freak table I've already got with freak size. Switch mode, switch octave. Those are the knob values, which I think I've already got those in. These are also mode related, so mod switch and waveform is equal to 0. Frequency switch and mod switch are the positions of the switches, and we already have those. I guess I'll just take these. Up 3, mid 1, down 0. Mode and octave are up 1, mid 3, down 0. And that represents wave folding FMAM, right? Mahalo's here. The weather sucks. So to your captive audience. All right, well, that works. Good to see you, Mahalo. Yeah, boy, we don't have a bridge anymore in Baltimore, huh? Seeing that stuff go down. I think I've been on that bridge twice in my entire life, and I live like 10 minutes away from it, 15, 20 minutes away from it. Actually, how long does it take to get to Baltimore? I think it's like a half hour to an hour. It would take 3-ish, depending, to get down to DC. Yeah, craziness. Like a cargo ship loses power, gets the backup generator on, and it's still not enough to kill its momentum before it smashes into that pylon. And there should be, hindsight being 2020, some bridges have stuff around the pylon so that a huge ship can't actually get to the support. It was crazy how it just popped. And there were people that were like going through the workers were like, they closed it off and people still went through. They were that impatient. Like, dude, the bridge is gonna like fall. Like, what are you doing? But yeah, now there's no bridge there, so this is gonna be a crazy thing. I was wondering when the next crazy thing was gonna happen in the news. Why are we making so many wavetables? It seems like kind of a ridiculous thing that we're doing here. PWM set channel, mod 2 wavetable. Yeah, I guess table set, and then mod 1 and mod, you modulate the wavetables through. I guess that's how we're creating them. I think I can get rid of the test program. Don't save the changes. I think I saved it over the test program once or twice. This is going to start running everything really slow. Wait, why did that settle into 1017? I guess that's what we got before. Okay, so close that. Oh, we can turn off the 6 volts too. Maryland making international news. Yeah, it's Groovy's home slice. I think I've been on that bridge twice, and I think the times that I've been on that bridge were when I accidentally went around the Beltway instead of going through the center of Baltimore through I-95. I accidentally got on the Beltway once or twice. Crazy news, though. It's insane. An entire bridge. I should be playing a bridge building game. I should be that crass, right? Driven over it like 50 times at least. Yeah, I never take that one. Yeah, when you accidentally get, and I've done plenty of times I've gotten on the wrong Beltway in DC. DC Beltway, I know that like the back of my hand. I know where to speed and where to go slow. But the Baltimore Beltway, you see signs for it, and once or twice I have been diverted due to traffic or just me not paying enough attention. Yeah, DC, I don't know if Baltimore is still doing it, but DC had perpetual construction, and they would put up a speed sign, and then there would be a little SUV ahead of it that would be taking pictures of your license plate and automatically giving you a ticket for speeding. So it was a whole cat and mouse game on certain weekends when I'd be going up and down those routes, and there were ways you could spot that they were actually doing the speed camera or not. There's all kinds of little tricks. So I need the Erica Synths code that we made. What was that one called? 3K programs, basics, bell bands, crime, public basics, speak and spells, 4046. What was that thing called? Flash AVR, dude. There's for some reason a video file. Kinks, parts, public basics, tester, tides. None of this stuff is useful to me. Nope. Where did I put this file then? Huh. I know I saved it. Oh, really? Oh, no, they're not. They didn't put up permanent speed cameras? Okay. That's frightening if they did. Are they still using the van? I was familiar with those areas like years and years ago. I haven't been back in a long time. So maybe we need to look in the Arduino folder. Because it's not, I don't think it's so, I did this so long ago. It seems like yesterday, but in my sketchbook, it's just probably not in there. Tiny 85 analog write, sample VDF, responsible analog radio, record engine, pulse, pin 5, packet test, over the air, hello world, Noratake noodling around, hello world, Arduino basics day, sample VFD, responsive analog read. I don't know what that one is. Pin 5 test? I don't think that's right. Vans for every construction zone. I hate them so much. I hate them. Where did that window go? Pin 5 high, weight 50, pin 5 low. Okay, that's not it. What did I do with this code? Over 100 miles an hour? Hit each other, sent one flying into the work zones. Oh, Jesus Christ. That's ridiculous. Yeah, is there like a cannonball run for the Beltway? Where could I have saved this? It would be either Erica Synths or Reverb. Code dump, brewing, burn the subs, channel point, EQ, no, that's a backup. Fonts, GVM. Into the joystick, I guess. Came in filtering, letters to people that I've written, links. Wait, is this in the stream one? Jeez. Meme text, what the fuck was that? Mill mods, Omnipod, PC lights, Pico DSP hack. I think that's actually it. That is. People get competitive when speeding, yeah. I'm just wondering if there's like an official time around the Beltway. I know people used to do that, Beltway bombing, but I don't know if it's a thing anymore with all the cameras that they put on everything. So we need to get this code in just so that we remember where our button was set. So this is our framework program that we're putting together. And so I need to bring this code into the main code. So EEPROM.h. I don't know if the RP2040 can, I don't know if the RP2040 is compatible with EEPROM stuff. I guess we'll find out. It's crazy though that the bridge was just completely obliterated by the strike. Okay, so here we're doing. Wonder why I'm probably because of the core that I'm using. I'm using weird designations for the pins, which this is a valid way to do it, and then you don't have to shuffle around with what pin number and what digital out number. Wait, why is it commented out? The bouncer attached button pin, interval of 5, mode init, change mode. So mode init is probably where this is happening. I'll copy that and we'll take that whole program. It's mine now. It's my program. And then table set is actually, so maybe we need to read in the waveform up here because table set uses mode. So we'll do read in the waveform first and change mode we don't need to mess with. Mode plus, mode right, change mode. Switch, mode, case. Switch mode, squad. Okay, so there's our mode change, or that sets the mode. That's change mode. Init. Oh wow, that's okay. Locale and then mode, okay. So That's fairly simple for an initialization. Almost like I don't need all this stuff. Did it hit it dead on? I had trouble seeing what it, because it looked like all the stuff came out for the viewer's right side of that pylon. I guess it was pretty much, it just deflected over to one side. It's crazy that that would happen. That's so crazy. Gadgets feel like magic. It's a little bit, yeah, a little bit. This code is a mess. This is supposed to be a nice clean framework for our program, and it's just not. It's just not. I don't really need all this stuff. So if that's equal to that, do that, and then here we do, actually we could do that a little higher up. If waveform is greater than the number of mods, blah, 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 and then we do that, and so when we're done with the debouncer, I guess, we can do EEPROM put locale mode. So save prom. So that'll just save our prom state. We need our locale variable, which is something that we can change. And so instead of locale, I guess what I'm going to do is just do prom location or something like that. Prom L. For EEPROM location. So prom L. Prom L, and then that's actually waveform. Like that. Prom L waveform, and so when we gather it, we're just going to get, so I guess I'll just put it up in setup. We don't need a function for that. And then this would be prom L and waveform. And so now we just save our waveform to the EEPROM and get it back out. What variable did we put in here? UN8T. So we'll make it a UN8T. Well, I guess we could just leave it as an int. This doesn't have any value, but waveform is set as an int. We'll just keep it as an int, whatever. There's so much overhead with these microcontrollers. We don't need to be that crazy about our inputs. What are we saying over here? Sorry, I got Windows over stuff. The scroll of bounce, yes. Casting text spells that take weeks to write. It still feels kind of magical. I resubbed it, didn't even show the thingy. What the? Oh, no, I see it over there. Did it not show it up here? Damn it. Yeah, Groovy something. 57 months. Thank you so much for the resub. There it is. Now you got the Nixie tube by your name. What you talking about? Listen, this is going to happen like Wednesday probably. I have to see what the schedule's like for the local barber place, because I'm gonna get this all chopped off. Enough is enough. This is getting a little ridiculous. I'm getting comments like every day, every other day sometimes, about the hair. So this is enough is enough. This is ridiculous. It's getting mullety back there. I have 5 viewers right now, okay? And it's because of my hair. It's because I'm doing programming. Programming is a little bit cerebral for a lot of the Twitch audience. It's a little bit cerebral, but yeah, these are magical spells that make the computer do stuff. Everybody dead. Why everybody dead? So the LED blinking, where's that going to happen? If I put that in with the switch cases when it does actually switch modes, I guess I could just have it blink for the number of the mode, but then I need to set up the timings for it to do that. And I guess it would be better in the switch cases. And I can basically copy what do you call it? DOS Micro does with their indicator light. They do long blink is equal to 5. So long blink, short blink is 6. Yeah, we're programming Arduino, and we're taking Hajiwo's VCO code, and we're making it into something better, something a little bit more understandable, and it's helping me figure out what this code does in the first place. Like, what's the scheme behind this? How are they doing what they're doing? So our first task is to frame out how this code works. We don't actually have to calculate stuff and get values, although I did do a little bit of that just because I got sucked into it. But we don't have to actually calculate or output anything. I'm dealing with all of the inputs. So how are we handling the analog inputs? How are we scaling it? How are we doing test printouts so that we can get stuff into the right ranges? How are we, this and that and the other thing? So yeah, we're just trying to set up the framework, and then we'll do the business of the DAC. But once I get this framework going, that can then apply to other designs, basically. And also it very much lets me learn how the program works, which I need to do if I'm going to be able to master this hardware and actually make it into the universal style module that I want it to be. Boop, 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 boop. 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 This is the boring stuff in the engineering. This is why God, Uo's lab sits there blowing stuff up and applying pneumatic pressure to cylinders and stuff. And while I do like doing that stuff, and it's kind of fun, I don't want to get injured. I don't want to get like a serious injury. Didn't Electro Boom get like an injury recently? But yeah, I don't think I want like stuff flying around at high paces. When we do get into the wacky zany stuff, it's it's fun, but we do a little bit of more hardcore stuff over here, like actually programming microcontrollers, and I try to keep it accessible to people watching. Obviously, you can see by the fact that I have 2 or 3 viewers. The 3 of you are here because maybe you can follow code a little bit better, or you just want to hang out. I appreciate that very much, but this stuff is tough. This stuff is like very difficult to keep up with. There to there. It's a very strange way of handling stuff. Like this equation, I should probably pull out into like some variables, some defines. I contest that. I don't think lawn darts travel at 80 miles an hour. Those have been proven to be pretty. How fast does a lawn dart go? How fast does a lawn dart go? The truth about lawn darts. Terminal velocity of a lawn dart. I'm inventing a new low-cost weapon, and I need to know. Okay. African or European? Yeah, they are not legal. So we're getting up to 50 meters a second. The red ones are faster than the blue ones. I never made it without biting. Hold on. I have a spam call. Hello?
Hello. This is an important announcement from Health Partners, now part of Health Health Needs. We don't want you to lose your health care benefits.
Health announcement. Okay. Jeez. I already got the approval from my health insurance, so I don't have to die this year. Microsoft, no, not again. God, that was so bad. I had to make like an emotional plea for getting hacked. 50 meters per second to miles per hour. 180 kilometers per hour. That's not miles per hour. 111 miles an hour. All right, so 80 miles per hour. I guess lawn darts are in that range. I don't know about the lethality per speed, but oh yeah, anybody who hasn't seen it yet, this is what Ben Gizmo put together based on those polynomial equations. you can see how the wave folding happens per the mod variable. Going from 0 to 127, it'll wobulate all of our wibbling. So you can wibble your wobbles. You can look at multiple ones compared to one another. I don't know if this is every single case, because there's two different wave tables. There's an AM and or it's the FM and the wave folding table, I guess, might be different from one another, but that's really cool. Yeah, it's just speed, shrapnel, and energy and all that stuff. There's a lot to physics. Physics is awesome. I just don't want to, have any physics affecting my body in sort of the engineering sense of things exploding. I really hate that this number is just sitting in there, but I guess that's just part of the equation. It sounds like a dirtier sine wave. Well, someday we'll be able to listen to it. I just need to get through all of this obnoxious programming. So based on the prom location, what we're doing is we are coming in here and we've got eprom.h. There isn't any other stuff that I need to do. It's actually fairly nice to have such simplicity in the code. So we're coming down here and we're initializing all of our variables. We're giving them initial values, coming down all the way down here, and then we set up the debouncer. Then we go into our setup and we set all of our pin modes. Then we eprom.get prom.l and we store it in waveform. So now our waveform is set. We can do a table set, and when we do a table set, what that's going to do is that's going to take the value of the waveform, which this is the original code. But when we do table set, what it'll do, table set is a massive switch case. So in table set, we make the initial wave table, not the modulated wave table. We make an initial wave table, it gets modulated, scaled, and then put into a second modulated wave table. Why it does this is beyond my understanding, but I suppose those other wave tables are being created based on this one, which is only invoked when the button gets to a certain value. I think that means that we are ready. Oh, I need to set up my LED engine. I need to set up an LED engine that's going to indicate what wave table we're in. This is Morse code. There are Morse code translators. So in table set, if mode switch waveform wave table is equal to case 0, 1, 2, 0 to 256. We're going to get these loops out of here. We'll just do, we'll have a different function that'll be able to do this stuff. 0 to 128. Why does it vary like that? Wavetable of I equals 511. Oh, wavetable I plus 128 equals negative 511. I see now. All right, so let's break it up. Break it up. 0 and 2 are the only modes in wavetable. Okay. So that would be switch. So what do we call that? The Hajiwo code is starting to make sense to me now. So mod SW. So then in table set, we have two if statements on that. How else can we do that? Can we do that a different way? No, because we need to invoke table set based on where the switches are. I guess that's just how it's going to work. Okay, so it's time for not table setup, that's the octave select. Do WAV as our output. Button handler saves to the EEPROM now. It runs table set, and table set will blink the LED. Table set sets wavetable based on mode and waveform, and blinks the LED. That's a big function to have do all that stuff. It seems like it should be in a slightly different, like, well, we'll do this. If mode, or it's what is the switch called again? The switch is, I flick my hair out to the side. Oh, there we go. Oh, get rid of it. Nah. I guess I could set up a function that would blink the LED based on the mode number, but the LED blinking is going to be a little bit more dynamic than that. It's not just going to be counting the LED, because if it sits there and blinks 8 times, that's kind of hard to read. So it should do, 5, 6, 7, 8. Which I don't know how to turn that into a function. Actually, that could be if mode is above 5. So maybe we do but the LED blinking engine is supposed to be a little bit more versatile than that, right? I'm going to be putting stuff into a table of values and then incrementing through. So what I'm thinking about right now is just what I need to set up here. If table set, well, if mode, okay, mode is not mode anymore. Mode is, what is it? Mode switch. Mode SW, if mod SW. Mod SW is equal to, and then it was not 0 and 2. It is instead 2 and 1. So mode switch is equal to 2. Then I'm going to do function here. If, I guess else if. I don't like doing else if. Yeah, we'll just do another if. Equal to 1. 2 and 1, what does that represent? Three, 1, and 0. Is that not that wasn't the numbers we got? Okay, so this get rid of this. Get rid of this. Those are wrong. Those are wrong. Wouldn't be frequency switch either. The octave switch. Oh, that is what it's called. Oh, and we haven't done anything with the octave switch yet. Okay. Wait, where are my switch readers? Button handler, make frequency, read analog, table set. Oh, I'm not even doing it. Okay, so switch handler I need. I need that switch handler. That's not in this code, it's in the other one that I closed. Opening and closing windows takes forever, huh? Twitch won't let you use more than one word of Morse at a time because the divider is a slash. Huh. Do I need to put that comment into a Morse translator? I don't know if I do. I'll try. Let's do, and I'll do it off window, Morse translator. It's very easy to Google these things. It just says hello. Okay, where are we? We're looking at table set. This is the original. This is the test code that we're running right now, although it's been doctored a little too much because I accidentally wrote in it. Dumb. But we're looking at the switch handler. A lot of code reading today. Switch handler. We're just going to take that carte blanche and pop that into our functions down here. So we got the frequency maker, we've got the button handler. Hit save on that. We've got to wait until everything saves properly. So switch octave and switch mode. Switch octave and switch mode. Wrong way around. There we go. And then our octave and our mode are handled differently because it's a 3-position switch with an input pull-up on both ends. So we've got input pull-up on 2 pins. When you switch it, it will set one of those input pull-ups to 0. When you have it in the middle position, they're both 1. So the way I have it is doing bit sets, and so it ends up being the numbers that are actually expressed in this right here. So if I switch this one up, you can see mode switch goes to 2. 2, 3, 1. So 3, 2, no, 2, 3, 1. It's not in any order that would be functional mathematically. I don't really know if I can do anything about that. How can we do something about that? I could have these bits right, and then it would be, well, the octave is, how does the octave switch even work in this? Well, Hodulas code is going to be doing it in a weird way too. Which one is, okay, so the octave is P4 and P3. P4 and P3, what's the number behind that? I don't remember. So we'll look for a digital read. So that, here we go, here's the octave switches. So when 0 and 1, right? 1, 1, so that means nothing is switched. We're on the base octave 1 in the middle. When you flip it either up or down, it goes to 3 octaves or 0 octaves. So it would be 0, 1, 3. Yes. How would we make that? How do we do that? If I inverted this one, well, then it won't be 0, 0. So 1, 0, we would need to be 0, 0. So we invert that one. That becomes a 0. This becomes a 1. This becomes a 0. If we invert whichever one pin 0 is, then we can actually make, we can make them be 0, 1, 3. That actually works perfectly. Unfortunately, I can't really test that. So this would be octave, position 0 and position 1. We want not position 1, so that it can be 0, 1, and 3. And then we can just directly apply octave switch to everything else. That's nice and easy. So when it's in the middle, it would be 0, 1 instead of 1, 1. When it's on that position, which is octave select 2, which I need to make sure we've got the right one here. Octave select 2 is D6 or P0, which is this one up here. And the 2 is inverted, so that would be 0, 1. I may have it backwards. Because P0 and P1, I would need D6 and D7. Well, this one, it's marked over here, P0 and P1. But when the switch is switched, it actually connects the one that's the opposite direction. So if P0 is up top and P1 is down below, we would want P1 to be inverted and in that other position. So this is where we just reverse these two here. Where are we? So we want 2 and 1. So that when I flip this up, P1 is set to 0, P0 is set to 1. We had it right the first time. Yeah, because what'll happen is I'll flip the switch, and then the one that's not switched is set to 1, but we're inverting it, so it's set to 0. And when I go into the middle, that one stays 0 because it's still not switched, which gives us 1, 0. Damn it! Wait a minute. No, 0, 1, because that's the other direction where position 0 is all the way to the right. And okay, and then when I switch it the other way, then that one is inverted, so now it's a 1, and so our second position's 1. Doesn't make any sense. Wait, the other one's a 0. 1, 0. Or no, it's 1 and the other one's a 1, so it's 3. Okay, yeah, that works perfectly. We just not digital read. Okay, so I think that's perfect. That works exactly right. So when we switch it, I'm just going to review this. Switch it up and P1 goes to 0. P0 wait, P0 and 1 are mode. Okay. P4 and 3. Okay, well, that's the lower switch anyway, but whatever. P4 and 3. So I switch up and I set P3 to 0, which is octave select 2. Okay, this one is backwards. Because octave select 2 goes into the nth position, and if I switch up, it'll be setting the 1 to a 0, which then gets set to a 1, which means 1, 0, which means 3. So I don't want that, but I want 2 and 1, so that if I flip the switch up, P3 goes to 0. That's octave select 2, which goes... Damn it! Did I get it wrong again? Hold on, my brain hurts. My brain hurts right now. Let me write these down below so I don't forget it. So octave select is P4 for 1. So if I switch the switch in the switch is in the middle, right? Switch is in the middle. So P4 and P3 are 1. 1, 1. P3 gets set. Oh, I put these on the wrong. Right, octave select 1 is... Just bear with me for a second here, Chad. Octave select 1 is P4. Okay, 1 is P4. Switch is in the middle. 1, 1. But our digital read is the opposite. Switch is in the middle becomes 0, 1. So that's correct. Let me do it for you guys. 0, 1, right? Because that digital read of P4 is set to 0. It's the opposite of what it is. So switch is in the middle, 0, 1. I switch the switch upwards. That sets P3 to 0. Okay, hold on. P4 is untouched. Switch it up. P4 is untouched. So the 1 becomes a 0. P3 is set to 0, so we've got 0, 0. So that's 0. So we go from 0, middle position is 1, and then when I flip it down, P4 is set to 0. So, yeah, P4 is now set to 0, P3 is 1, and P4 then becomes 1. 1, 1, 3. Okay, so that automatically puts the numbers in for us. Cool. We can just multiply that by the octave now. Now that it's 0, 1, 3, just like it's set to. It's supposed to be. Boy howdy, is that little bit of logic really messes with you. Mode select doesn't matter because we've manually coded in the mode based on them going into position the way they are. I mean, I could make that a 0, 1, 3 switch, but it doesn't really matter. We can just manually set them. Whew. Okay, so now that we've cleared that up, what the hell was I even up to? Oh yeah, the modes where, well, that's for octave. For mode, FM, AM, and wave folder are a little bit different. So AM, it would be modes, 1 and 2 are the ones that are used by mode is equal to 1, mode is equal to 0, 1, and mode is equal to 2. But then the wavetable is set up in mode 0 and 2. Which ones are those? 0 and 2 are which modes? Switch mode squad. 0 and 2 are the two ends. So it goes wave folder FM AM. And FM doesn't need any of that stuff. AM, I guess, does need the table setter. I'm gonna steal this and bring it down to table set. So it's 0 and 2. And 0 and 2 are which ones? AM and wave folder. Doesn't do anything for FM. FM is 1, 1. So that would be 3. And then the other ones I need to figure out. So if I look at serial, the serial output that we have going right now, this one, 2 and 1. Modes 2 and 1 are the ones we want. Jeez. Okay, so this is the original. This is the one we're frameworking. 2 and 1. And 2 is which position? 2 is position. Having the serial print up helps massively. 2 would be wavefold. Actually, we could just run that as a function. That cleans that up quite a bit, huh? Table set. And of course, this won't get invoked unless... I don't need this if. I don't need this if in the button handle. I don't need that. What we can do is in the button handler, I can just do table set. And the mode gets stored every time this debouncer is... I guess we don't want to save every single time the button handler is run. That's stupid. That's stupid. That's stupid. What a stupid idiot. What a big, dumb, stupid... Look at this fucking idiot. Stupid. So yeah, let's put the EEPROM thing. If the debouncer fell, then boom, we save the EEPROM. Doesn't need to be outside of that. Nice, simple functions. So yeah, if the debouncer fell, we add one to the waveform. If the waveform is over the number of waveforms that we have, over the number of modes, we set it back to 0. We then set the table, which will do or not do, depending on what wavetable is specifically called upon, and then we save the waveform number in EEPROM put. How is the waveform being handled in AM? This may be a question for later. That may be a question that I want to answer later. So much code and software going into this thing. So yeah, much simpler with that, but now we need to make wavefold and AM modes switch cases based on waveform. And so this is sets wavetable, no, sets mode, or rather runs mode set thingy. Or doesn't. I'm not a cop. So, should we do it right here? I guess so. Void wavefold. And we'll have void AM too. So then we're setting wavetable based on, what did we call that thing again? Wave mode? Waveform. Based on waveform. On the waveform. Also LED, hee hee. Or should it do the LED there? Maybe it shouldn't. We'll set it up first and then we'll figure it out later, I guess. These polynomials are going to be quite a thing to do. Didn't we did a bunch with the polynomials last stream and figured out a lot of the stuff that's going to go into them. I don't know if I made a function for that yet. So this could be where we actually make a function for the nomials. Where did I store that? Did I not? Did I lose it? This also should go into synth. I guess I could do it right here. Bam. Okay, and then we're looking at, well, it's either of these, 4046, or it could be in the right folder. Test, chords, frame. The test we already have open, and it doesn't have any of that work in it. I wonder if I lost all my work after last time. I might have. We'll see what the rewrite has in it. If I have any of that. Any of those polynomial things. Where was I working in last stream? I don't remember last stream. I just don't remember it. Do we have a notepad file, or was it in here? Well, it wasn't in here. This is all of the big FM tables. Like last time we set up that test program just to see that everything worked. Saw, sine, square, triangle, octave, saw, FM1, 2, 3. This is a previous, I guess we need like an FM polynomial kind of thing. How does that even work? So wavefold in FM, or sorry, wavefold in AM, and then the other one is FM. I have read all the analogs and I have that stuff. Let's get this out of here. I'll put that at the bottom of the program because I guess that's just where we're gonna work. Actually, it should be above the test functions and above the setup functions. So this would be like the table nonsense. Table nonsense, and so we've got our wavefold and our AM, and then we need to go through, I suppose, just a switch case. So we already know that the mode is set, so we need to do switch waveform. Was it a... No, I don't have a Notepad++. Bounce to keywords, RP2040, synth. I don't know, I might have lost all that work that we did yesterday. Shit! Well, oh well. I guess I know what I'm about at this point. Okay, so where's our original Hajiwo code? That's this one. OG Hajiwo. Now, I've seen some weird stuff with switches and cases. I saw something where they broke down a switch case to be this like compact thing. It was like case 0, and then thing, and then break. I don't know if you can do that with a switch case. It might have been an if else. To be if. Oops. Oh my god, I'm messing it all up. How would you do that? I don't know. I don't know. Where did I see that? I should look for that. Do like Arduino compact switch case. Because each of them are doing like one thing, right? This is like I don't know what it'll end up looking like, but demo code explaining switch case statement with Arduino. Search has gotten really bad lately. It's like I can't find anything relevant anymore. Control LED with a push button. No. Yeah, this is like none of this stuff is where did I see that code? There was a really good like little snippet of code that had a really compact switch case. Or something similar to that. And I think it was part of, actually, wait, I do remember where it was now. It was in the original code in Hajiwo's notes site. And it was not this one, but it was this one up here. Actually, wait, I've got it in Arduino.cc. I've got it in the Arduino thing, so let me open it up. File open, and we go to VCO only, and this is the alternative language of this code. This one seems to be a little bit more catered towards being a synthesizer than being a VCO, which is an interesting way of doing it. There's a lot of features in here that aren't implemented for the VCO or aren't even relevant to the VCO. There's a lot of pitch things going on too. I think this might be the chord VCO original code, but within this there was something kind of neat. Oh yeah, here, I did the same thing. PWM init. Process. Volatile. A lot of crazy stuff. Here's what we're talking about. So that would be a nested if-else if. With an else. 0, 1, 2. Here it is. There it is. Look at that. Note on off break. So that's an interesting way to do it, and I may steal that because that is nice and compact, and it gives us a lot of stuff just sitting right there, a lot of mode stuff just sitting right there. So we can do a why can't I? Oh, it's all the way at the top. So in our code, there's now very many windows open, and I'm starting to get confused. In our frame code, we can have switch waveform. And then this, like that, and then we'll do case 0, and then it would be FM module, and then 1, 2, 3, 4, 5, 6, or something like that. I don't know how many there are going to be in this thing yet, and then break it. One, 2, 3, 4, 5, 6, 7. I count good. I count good, and I math good too. Depending on how many modes there are. And we got to look into that code now and kind of break it down. We don't have a default. Yes, good, good. Yeah, this is a much easier to understand. Oh wow, they have case and then if. They have if statements inside the cases, and they're splitting it up to make it more readable. This is nice code. I like it when people do the stuff like this, and you can read their code and what it's doing. Okay, and then we'll have a function down here that'll do the polynomial thing. So I'll call that FM module. Void FM module. And this will do sets the wave table. And we need to figure out which one it is. So let's go down to mode is equal to, oh god, which one is which? Which one is which? Well, I think there's yeah, mode is wavefold. So we're in, not quite in the right, no, this is, if mode is equal to 0, wavefold, do that. Mod 2 wavetable I. We're in table set still. So void table set, mode is 0, that's wavefold. Switch waveform, case 0, and then 4, I is 256 wavetable of I times 4. Case 1 is a different equation, sine of 2m pi. So saw, sine, square, triangle. And then octave saw. The question is whether or not I want to put the stuff directly into this, or if I want to take it and make functions for each one like I did in the other one. Maybe we should go direct, because these are relatively compact. Although we do have multiple for statements in here. That's going to get messy down here. Well, for the FM modulations, I have a modulator. And I guess here we can just call upon the power of saw. Yeah, let's do wave functions. So void saw, like that. So this will be saw, it's the first one. We're just running saw straight up, aren't we? Saw sine. Sine is, doesn't that get its FM? Because that's just an FM equation. Sine is just the, yeah, so that's going to get an FM modulation. So you can do like saw, sine, square, triangle, and then oct saw. What does that even do? Huh. How's that different from saw? Oh, it's like an extra I plus 128 on there. That has a lot of actually equation-y stuff going on. Okay. And then we have FM1, FM2. Probably FM3? FM3. Now, if mode equals 2, what do we have? Saw, FM1, 2, 3, non-integer FM1, non-integer FM2. So yeah, those are just, those get crazy. Although saw is just wavetable blah blah blah. Huh. Wait, that's not saw. Maybe that's a cut-paste error. So I'm just going to steal this, and I'll, oops. Steal this, and we'll put that. I mean, maybe it should be wavetable equals saw, but then you got to iterate through. So saw is just going to look like this. And wavetable of I times 4, etc. I guess you can't do wavetable equals blah blah blah. And then literally everything else is an FM modulation, isn't it? No, square and triangle. Void square. Lord Squay. Lord Squay. We are ready. Lord Square. Void square. Void square. What is square? We're up here. All the way up here. Void loop modulation. Mode is equal to 0. Mode is equal to 1. And then FM has all of its own things. Mode is equal to 2 has its own sort of smaller thing. And then table set has 2 different things. Jeez, this is complicated. Okay, so mode is equal to 0. Saw wave looks like that. Sine wave looks like that. Square wave looks like this. So we'll just take that, bring it on down, put that into there. There's our wavetable equation. That looks very familiar to me. Wait a minute. I just doubled saw. Okay. This is supposed to be square. Saw sine square. Did it not cut and paste? There. Jeez. What? Okay. So square wave from 0 to 128, it does I++. They're supposed to be from 0 to 256, but square is just a positive and negative integer. So you have 511 and then negative 511. Why 511? I guess it gets multiplied later. When it's output, it gets multiplied or something. I don't know, but I guess that's just how we're doing things in here. We go to 511. Maybe that's because of the octave scaling or whatever else is going on. Strange. But that's just to set the levels of it, I suppose. Triangle. The void triangle. The void triangle. Take all this. Put that there. Bring it back. Bring it forward. Tab over. So for the triangle, we are doing something similar where we take opposite halves because we're going up and then down, right? It's just a ramp up and down. And so the equation ends up being I times 8, and then you add or subtract it from, add or subtract it from that maximum value. Or subtract it from the maximum value, or subtract the maximum value from it. That's how we do it. So it's just ramp for the 128. We can do it two at once. We can do it a little faster. Put a little space in there. So all that's left, oh, octave saw, never mind. Octave saw we also have to do. So we have a void oct saw, which is given by saw is actually saw wave. It should pop back down. So for just I up to 128, I times 4 minus 512. So it's like a ramp plus I times 2. Huh. Strange. And then from above that, I times 2 minus 256 plus I over 4. I guess no, that's not a wait, but a sawtooth is supposed to go like that. It's supposed to ramp up and then bop straight down. I don't know. Oh yeah, oct saws, yeah. So saw, square, triangle, octave saw, and then everything else is FM. FM, 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 non-integer multiple FM. Okay, cool. So we have all that. Geez, now I gotta find out where I did that work the other day, where we actually figured out what the polynomials should look like. Well, we should also plug them into the, yeah. So wait, sine square? It's saw square. Oh wait, saw sine, yeah, saw sine square. Sorry, saw sine square. So this would be the FM modulation. This one would be square of nothing. I'll line up all the breaks, I guess. I don't know what the numbers are going to do to the spacing of everything. No. What the? Triangle. Octave saw. What did I call that? Oct saw. We need semicolons in these. Really? Okay. All right, so the FM modulation scheme is going to require a little bit of massaging. It's going to require some default values, I suppose. What are we... well, we have different polynomials that are triggered by different integers, and we need to either zero them out or allow them to pass in. The question is whether or not, well, we need to change the values of those polynomials as well. It's almost like we need a structure for this, which is kind of a lot. I don't think the structure is really going to solve our problems here. I think what we need is a default value. It's just going to be complicated. I guess it's going to be, well, let's take a look at some of these things. I mean, we did a little bit of work with this, but oh yeah, that's right. That was in our MS Paint notes. There's all of our work. Ah! Oh my God. All right, so we're a little bit into wave folding there, but this is the star of the show right here. We have this big old polynomial, and it uses mod, and it activates different. So we have different modifiers. We have different numbers under the modifiers. 2 pi I e over E1. 2 pi I over 256 plus mod over 128 times sine. 2 pi I a over A1 plus, and then there would be like a kill A. That would go in front of that, and that would set this to be 0. And there's a 1/2 in there if it's FM8. So 511 times, and then this whole thing. So in our FM mod, okay, I'm starting to remember. I'm starting to remember. So for I is equal to 0 to 128, right? Let's double check on that. So I can start writing this thing. Where are we? This is just wavetable. 2 saw FM1, FM2. Oh, this one has a saw in it too. But the saw is just 2m pi I over 256 times 511, which is, we can do, I mean, we can, is it 2 pi I over 256? That's just, if we kill A, then we have a saw. So I'll turn saw on to kill A. Saw is kill A. No. So in FM modulation, we'll start with a for loop. For I is equal to blah, 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 and then we have bool kill A is equal to 0 by default. So A is killed by default. So if I just run FM modu for saw, FM modu, that's it. That'll just run with the default values, and it will kill A. And if it kills A, then it's 511 times pi. Sorry, 511 times sine of pi, 2 pi I over 256, which 2 pi I over 256 is a saw wave. Okay, cool. Hey, we simplified something. How awesome is math? Math rules. Okay, let's not get ahead of ourselves, because that's like the dumbest thing you can possibly say. Okay, so sine of blah 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 blah. So saw, we get rid of saw. We don't need saw. And then FM modu starts with saw. Wait. Where did I get sine of 4 whatever? What is this? Wave table of I of 4 times what? Let me bring saw back in here just in case. Oh, saw's a little bit different, isn't it? Wait, but this isn't, where did I get this from? Because this isn't the right one. How come? Oh, it was the second saw, which is actually FM1. It's an error. Okay, yeah, okay. So yeah, this is where we actually start. This is misnamed. That, or sorry, this is misnamed. It shouldn't be called saw because it's wavetable of sine. But okay, copy this, and then we get our nomials in here, and we'll just start in on it. Wavetable I of sine. So it's kill A default is 0, and then we have mod A is equal to, what is that defaulting to? I mean, if you kill the whole polynomial, nothing's going to happen with it. I wonder if this would be faster or not for the for the equation to evaluate. I wonder if I should evaluate this in steps or something. Have it do the most nested one, as in like this stuff back here first, and have like an if statement on that, so that if it exists, then calculate it and put it back in. Or if I do it mathematically by just having canceling polynomials, if it'll be much slower. What is the over under on that? How does that work? Should if statements get me out of doing a big calculation, or if I need to wrap them in, like do this circularly from the inside, depending on what's activated. Maybe I do need to do that. Because then it would be, yeah, maybe I should do that. So it would be all the kills, and then at the very end. So if kill A is equal to 1, well, by default, everything should be disabled. And then we've got mod A, B, C, D. Don't some of these change? Doesn't the 128 change on some of them? Uh, 256. 2 pi I 256, 2 pi I 256. Oh, none of that changes. 2 pi 11i 256 256. Where's my big thing of equations? I got that over here. Yeah, 256 124, 256 333. Yeah, that nonsense back there too. Oh my god. And then some of them are divided by 2. So I need FM8 mod is equal to 1. That's an integer. Or should these all be, do these all need to be floats in order for the equation to work properly? I don't know if that's the case. Hold on. No, I'm just thinking. I have so many windows open right now. Where are we coding? We're coding in this one. So then I need to have sine 2n pi times I 256. I mean, I can pass everything into the big equation, or I could do a bunch of other, like, smaller equations. I think first I need to check, so, oh, not that. If it would be, so, well, okay. I'm just gonna get all the information in here. So, mod A, B, C, D over integer. And so it would be mod ratio I could do, but that would be, then I'd have to evaluate that on my own, so I don't really want to do that. Is it really? Okay. I gotta look at the equations again. That would be in Which window? Yeah, see, the mod value changes. I'm calling it mod, but it's modifier is what I mean. 11, 7, 13, 19, so we'll have modifiers A, B, C, and D, I guess. Oh, wait a minute, but does that mean... All right, what's the original equation? Let's look at the original equation. Is it actually using mod? No, it's using I. And there's no mod value in those. Are they used earlier? This isn't even the one that I should be looking at. This is rewrite. We should be looking at the OG code so that I don't do anything stupid. OG code. Yeah, this doesn't have anything to do with mod. It's just when you go into the modulation, you add a mod in there. Wait, this is for FM. If mode is equal to 1, FM. So that's our main loop where we modulate this stuff. But oh God, when we're over here in table set, we don't use mod. We still have I of, that's always 256 for the initial. There's two different areas with this stuff, huh? Eleven, 7, 2.3, 6.3. Okay, so for table set AM and then wavefold, and then in wavefold we've got these FM parameters that are the same thing. So this is all just for table set. I'm going to take a look at these and put them all the way at the bottom of the sketch. For table set, and we'll take all these down to the bottom here. FM1, FM2. We got to simplify these and figure out how we can make them into a function, just one big happy function. And I'll figure out what to do with the rest of it somewhere else. And this one gets... I'll put the saw in anyway. Or no, that's FM1. FM0. Zero, 1, 2. We haven't even tested our framework code, which I guess is something that I can do, but this has wrapped us into the functionality of the rest of the entire system. So the 0, 1, 2. These are the same? No, they have a 5 in there. 3. Then 4. We don't have a 3, we have a non-integer. Non-integer 2. Non-integer 3. And then another non-integer 3. Jeez, these are annoying. So this is what I did originally. I was just taking those and spacing them out so that they would be readable. So this is our first polynomial, basically. 2m pi I, 256, and then we have sine blah 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 511. This number changes. This number doesn't seem to change anywhere. This number does not change. So then this whole business right here with the one variable in it is true for all of them, but we need that one variable. So kill A is not necessary. So then A is always present. I need to put this somewhere that'll keep it. Oh my God. Okay, close that. Chat is not talking. Chat is dead. They have died. It's alright. You can't stream with a dead chat. Why do you stream? So bool kill A is not necessary. Mod A. Default. It doesn't need a default. Should it be an int? I'll set it as an int. But shouldn't we be doing floats for everything? Wavetable of I is an... where is it? It's an int, so we'll stay in int space. Where's my function? There it is. So int mod A, I guess we'll start with it equaling 0, even though that'll mess up all the calculations. And then we have a, well, once we're done mod A, all the equations are exactly the same until it is done. So I guess we need an if statement in here, and we need to start with the most nested element, which is going to be the second polynomial, which is pushing us all the way out to here, but we're listing things logically from the front side. So I just need to figure out what all of my stuff is, I suppose. So it's like, all the way over here. That's A. And then after A, because they're all the same considering that. So we like the last element would be this, but it would be, oh, but the saw wave only uses that, doesn't it? Saw wave only uses that. So it would be, yeah, int or bool kill A is equal to 0. This is going to be a very confusing thing, because this will run no matter what. So default is saw. And then this would be, if we do that, I guess I can do int plus int mod A. No, plus mod A. But that's, wait, 256, that's inside of the parentheses, so we plus mod A, which defaults to 0, so that's still a saw wave. And then we keep doing a wavetable value of I is equal to, yeah, so we don't invoke wavetable until there, and we can just use the ints that we've already declared and everything else. So it would be like if, well, I mean, we could set if they're set to a non-zero value. If they're set to 0, then maybe that means kill. But the mods, they don't get to set to 0. So we'll just set them if, so then this becomes, well, no, this we leave alone, because that one is default to 0. So if mod A is equal to 0, then that just overrides and it never gets overwritten. If, and then we do mod B does not equal 0. Because then at the end we just add mod A. And oh no, but if mod A does not equal to 0, yeah, we need integers in there. So yeah, if mod A does not equal 0, mod A is equal to, and then we calculate that from whatever happens over here, plus sine. So mod A is equal to sine of 2 pi. And we're just working backwards through this. 2 pi, m pi 3, blah, 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 blah. And then we multiply that by 511. So this one, yeah, this one's still multiplied by 511. So, and then also this one would be mod 8 times. Mod 8 is the FM8. Int mod 8 is equal to, oh, actually, that can equal to 1/2? How does that work? Does it have to be a float in order to do that? But for right now, I'm just equaling it to 1. That's so weird. Because only in one of the modes does that actually do anything. So the default value for that is equal to 1. And so that'll punch in a 1, and it'll multiply this whole thing by 1, and then by 511. I wonder if I should divide 511 and do that instead. I guess I'll leave it alone. Confusing, though. So if mod A does not equal 0, mod A is equal to sine of 2 times 2m pi times, and then this would be mod A, I over 256. 256 is everywhere, too. We're trying to work outwards from it. That's a saw wave, or no, that's well, one of them, FMs, and that one is 3 times I, 256, 511, and then when we get into the more complicated ones, we have an E and an F at the very end, too. But we start, so where's our mod B? Mod B. Mode 7. It's all of our A's lined up, all of our I's, all of our 256s. And then we have variations here. 511, 511. This one adds one more thing to it, so that's going to be our B. And so sine 2 pi, so if B, oh yeah, plus mod B. And mod B is, wait a minute, plus mod B is inside of the parenthesis. So like that. So if mod A does not equal 0, we're adding all this stuff up, but mod B is going to default to 0. Mod B is equal to 0. I'm saving a couple of cycles, I guess, in whatever math evaluation engine is going on in here by checking everything. We don't multiply that by 511. We just let that ride. So if mod B doesn't equal 0, then it's pretty much the same thing, except we put mod C at the end. Mod B is equal to sine of all this stuff. And then we have a mod C. Mod C is 0. It's regressive. We just keep going back. How many do some of these have? These don't look as complicated as the other ones. And the other ones have different denominator values, though. So I don't know if I need to like default them to 250. Well, defaulting them doesn't really work like that. I'd have to declare them as 256 every time. I wonder if I need to do that, if I need to, because, okay, so on these, they don't change. Everybody's 256, everybody's 3, everybody's 256 on that one. They seem like they're pretty homogeneous, whereas if we go to some of the other ones, they start involving the mod parameter in there. And that's going to be a similar thing to make the mod 2 wavetable, but I guess we're going to make a new function for that, I suppose, because these have weird values all over them. That's what we were looking at before, but these are pretty homogeneous, and so I can get away with doing this. Because they, what are they doing here? Inside of this sign, yeah, it's 1, 2, and sometimes a 3. Take that all the way out to the end. What do these have? These have just bigger numbers. Like, take that way out there. Yeah, it's just a 3.19 is in there. Wait, that's not an integer though. This is messing it all up. But wavetable's an integer, so what happens if I just keep them as integers? But then it would have to be 3 instead of 3.19. Ah, boy. If I type them as an integer, like 3.19, it might change it to a float for me. That's just weird. These silly, silly things. There goes my dog. Woof, woo, 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 woo. Yeah, so it's just nested. It's just, there's a possible, what is it? This one doesn't get anything. This one's default. And then it's A and B. I think there's only 2 terms for this one. So A and B are the only ones we need here. A and B. So yeah, this one's just A and B. We don't need that C term. So if mod B does not equal 0, then we put this on it, put that stink on it, and then we only need A and B. If mod B does not equal 0, mod B is equal to sine 2 times what? Wait, 2 times 2 times. Hmm. 2 times m pi, not 2 times 2. 2 m pi mod A mod B times I over 256, and then that gets rolled into polynomial and goes through that, and then that gets rolled into the polynomial and goes to the main solution. So if mod A is 0, then it just shuts it all down. So okay, so we can program all of our modes using this now, which is a little weird, but it does work. Should work. I don't know. So what do? We do float. Those don't need semicolons after them. We do, oh yeah, and mod 8 we're not even using. So it really is mod A and mod B for this. And then we'll have a different equation that'll do the big wavetable 2 modulation. So this is a smaller function. So saw would just be, and now is this FM modu? Yeah, I guess this is FM modulator. Is that what we're calling it? FM modu. I call the other one FM mod modu or something like that. So this one is default for saw. Sine wave gets saw gets nothing on that term. This one, I over 256. Oh yeah, no, saw needs to get its own saw wave thing. Yeah, saw gets its own saw. Sine is just 2 m pi I. So there's no other term in there. There's no A or B. So it's just FM modu of nothing. And that'll give us the correct response due to the default values. Square gets its own thing. Triangle gets its own thing. Oct saw gets its own thing, which is a little weird. And then finally we have FM1, which gets 3. FM modu 3. And there's no B term. And then yeah, it's just 3. That's it. It's just an A and B in there. So this one gets 7. And then this one gets 2 terms. What is going on here? Okay. Sine of, that's the whole thing multiplied by, so sine of that. And so A is 4 and B is 11. 4, 11. That's it. So that is massively simplified from what it used to be. Now the next ones are these down here. Mode is equal to 2 AM. So wavetable I 2 pi m pi blah 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 511. It's not a saw wave, it's just a basic sine wave. So that would be the default FM modu. Basic sine wave. These don't need to be as spaced out as they were. Let's make it even prettier. No. There we go. Saw FM modulation, square, triangle, oct saw, FM module 3, FM module 7, FM module 4 and 11. This one starts with just your simple sine wave, then it goes into the same 3, 5. Okay, 3 and 5. So 3, then 5. Three, then 5. Everybody's gone. Then 4, 11. These are the same ones as the other one. 4, 11, and then we go down here and we got 1.28. What? 1.28, and then we have 3.19. And then 2.3, 7.3. 6.3, 11.3. All right, and then we line up all the breaks just so they look nice. All right, so that's our first modulation. There's 2 modulations on this stupid thing. So that's the simpler FM modu. That was easy. So we basically made all of these equations by just running commonalities together. Cool. So the next one is harder to do. And that one was table set. And now we have, which one, what is this? What is this? Yeah, these are the easier ones. Oh, wait, no, but these have, wait, these have different values on them. Which are these? The non-table set ones. So these are the ones running from mode. Void loop modulation. Oh boy. So this one is a different loop. It's from wave, well, different mode 0, mode 1, and mode 2. And then we've got these more complicated equations to run. Damn, what time is it? Holy crap, it's 4:30. All right. Well, I'm going to have to keep doing this. Probably spend my Wednesday doing a little bit of this stuff. But you get what I'm saying here, how we're going to do it. We're going to go circularly from the middle, basically. Yeah, really. I think I might end early just because it's going to be another 2 hours of me doing this. And I'm best to be doing this on my own. You guys are just going to see me scrolling through stuff and trying stuff out because I want to get this thing running. I think I can probably get it running once I get through all of this code. I didn't mean to have a coding day today, but we're getting very close to this thing actually functioning. And I've got functions in there from other programs that I know will be able to save the value that you've selected on the button. I need to come up with that little engine that'll do the blinking lights. But like while I'm doing it, I'm massively simplifying the code and coming up with schemes to kind of organize it a little bit better. And one of those schemes is by taking those sine values and basically working backwards through them to see which ones are set, and then going through the code and you know, making it work or not. So that's what I'm going to set up for the other FM scheme. That one involves the mod value, so it's going to be a little bit different. It's going to have like an extra variable in it, and it'll have a lot more parameters because these things get kind of complicated. As I'm staring at this code though, and as I'm looking at like the Hajiwo code, the original code, it's making a little bit more sense to me. I still have to kind of figure it out though. It's like there's like the default wave, then there's the octave that you apply and make a new table for, and then you do it, like, it's just a bunch of stuff that you got to do. And I'm wondering if there's a way to simplify this out a little bit more. Like once you make that wave table, you should be able to apply simple math to it and do other stuff, but I don't know. I guess it needs to like do the reflection and stuff. There's a lot more to this, and I'm gonna have to get deeper into the software. I used Stream today. I've used you guys. I used you as a means by which to keep me concentrating on stuff. But having done this much homework in one sitting, my brain is starting to leak. Let's work on burning the subs when we come back on Thursday, because I've got a radiator that has to go into that. We can, you know, use our mitts to put that together, and then maybe figure out some of the wiring that we have to do, and I'll scooch all this stuff off the desk and we'll get to that. Yeah, thanks for watching. This is an abrupt end. Let me just see if anybody else is around right now. I know Gonad is there in chat, but nah, it's just the usual suspects. The usual suspects. But yeah, thanks for joining me, all of you hardcore people who joined me for like pure coding. Here's your wonderful end card, and I appreciate the 11 comments that I got for this 4-hour stream. Sometimes engineering is boring. All right, I will catch you guys on Thursday. Until then, you know, hang out on Discord, whatever else it takes, right? I learned a lot. I hope somebody gets something out of this, because it is a very boring kind of thing to just sit here and organize code. You guys can see how my brain likes to put things together, and I'm starting to learn this stuff a little bit better. But yeah, we'll be back soon, and then, yeah, is that a light emitting resistor? It's an LER, light emitting resistor. We do need more like streams where we actually do stuff. So we're gonna work on burn the subs next, and then yeah, we'll kick it into Friday and figure something cool out to do for Friday. I have like family members that are potentially going into the hospital at the beginning of the month, so a couple streams might get interrupted by that, but we'll play it by ear, and I will always be on the Discord, so I will catch you guys later. Yeah, you should make it light emitting resistor, and it should be like the which one is it? There's one that's like day mode. I added it to our things. Hold on, where's that one? Now I gotta find it in the list, which is always the least efficient way to do it. It's the flashbang, yeah. Is that not on there? It should be on there. Hold on a second. I'm gonna find it. There it is. This one, flashbang. You need to make a resistor that does that. Or just do the meow with the resistor and have it get super bright. All right, I will catch you guys on Thursday. Until then, you can find me all over the place, but mainly Discord. Damn, that would have been much more poignant if I had gone to the technical issues page fast.